Before we get started, I want to congratulate you on making it to this point in the program. You're halfway done, which is pretty incredible. Let's take a moment to think about all the skills you've learned in your journey so far. You've learned the fundamentals of information technology, from how binary works, to the importance of user support in IT, to even building your own computer. You learned the fundamentals of computer networking and how the internet really works. And finally, you learned how to navigate the Windows and Linux operating systems, managing processes and software in the command line like a true power user. Great work so far. Before we dive deep into systems administrations and infrastructure, I'd like to take this opportunity to introduce myself, or reintroduce myself, for those who might remember me from way back in Course 1. My name is Devin Sridharan. I've been working in IT for 10 years. I'm a corporate operations engineer at Google, where I get to tackle challenging and complex IT issues. Thinking back, my first experience with tech began when I was about 9 years old, when my dad brought home the family's first computer. I remember my dad holding a floppy disk and telling me that there was a game on it. To my dad's amazement, I somehow managed to copy the game from the disk onto the computer's hard drive. While it may seem like a trivial task now, this device was just so new to us back then. Sure, I loved the different games I could play, but what I really loved was tinkering with the machine, trying to get it to do what I want it to do. While that floppy disk and computer might have ignited my passion for technology, it was actually my first few job experiences that really started to shape my IT career. One job was in retail selling baby furniture, and the other was at a postal store where I helped customers ship their package and became the one-person IT crew. It might sound odd that working in retail inspired my career, but I realized that I really enjoyed communicating with customers, trying to understand their needs and offering a solution. My first experience working directly in IT was in college as an IT support specialist intern. From there, I worked as an IT consultant to decommission an entire IT environment. This was my first experience working directly with a large IT infrastructure and pushing myself outside my comfort level as a college student. I bring these first few jobs for a reason. These experiences helped shape my career in IT. I knew at that time that I wanted to go into tech, but I struggled with where I wanted to focus my career. Starting at Google as an IT generalist allowed me to experience many different areas of technology. It allowed me to figure out the jobs I didn't want to do, and before I was able to identify exactly what I did want to do. I'm really passionate about IT infrastructure. This program is designed to help prepare you for roles in tech support, desktop support, or at a help desk, but it doesn't stop there. In this course, we're going to open up an even wider net of possibilities in IT by teaching you the skills you need to manage computers for a whole organization. If you're working in a small organization, you might need to do this from day one. If not, stretching your skill set will make you stand out in the field and prepare you for potentially taking on this work further on in your career. In this course, we're going to build upon what you learn in the operating systems course by teaching you system administration skills. At a high level, system administration is the field in IT that's responsible for maintaining reliable computer systems in a multi-user environment. While systems administration responsibilities can overlap with other roles in IT, a person who works only in system administration is called a systems administrator. Systems administrators have a diverse set of roles and responsibilities. They can range from configuring servers, monitoring the network, provisioning or setting up new users and computers, and more. Think of system administrator as a tech generalist. They handle many different things to keep an organization up and running. It's actually very similar to how IT support specialists work. You need to apply your diverse set of tech skills in different situations to help solve problems in an organization. As an IT support specialist, doing systems administration tasks might be part of the job. So we're going to introduce the skills and knowledge you need to manage organizations and systems to keep your skills well-rounded. By the end of this course, you'll learn what services are used in IT infrastructure. You'll also learn about essential user software for your organization and how to manage an entire organization's users and computers using directory services. Finally, you'll learn the skills you need to back up your organization's data and recover it in the case of a disaster. All right, it's time to get started, so let's dive in. Before we can get into the nitty-gritty of what systems administration is, we need to talk about what these systems are. Organizations don't just run on their own. Employees need computers along with access to the internet to reach out to clients. The organization website needs to be up and running. Files have to be shared back and forth, and so much more. All of these requirements make up the IT infrastructure of an organization. IT infrastructure encompasses the software, the hardware, network, and services required for an organization to operate in an enterprise IT environment. Without IT infrastructure, employees wouldn't be able to do their jobs, and the whole company will crumble before it even gets started. So organizations employ the help of someone like a systems administrator to manage the company's IT infrastructure. System administrators, or as we like to call them, sysadmins, are the unsung heroes of an organization. They work in the background to make sure a company's IT infrastructure is always working, constantly fighting to prevent IT disasters from happening. Notice all of the really hard work that sysadmins put in. So show a little appreciation for your sysadmin by celebrating System Administrator Appreciation Day worldwide. Yes, that's a real thing. In all seriousness, sysadmins have a lot of different responsibilities. Any company that has an IT presence needs a sysadmin or someone who handles those responsibilities. The role of a sysadmin can vary depending on the size of an organization. As an organization gets bigger, you'll need teams of sysadmins. Their responsibilities may be separated out into different roles, with job titles like network administrators and database administrators. Companies like Facebook and Apple don't have a single person running their IT show. But in smaller companies, it's usually a single person who manages an entire company's IT infrastructure. In this course, we'll focus on how just one person, you, can single-handedly manage an IT infrastructure. You learn the skills you need to manage an organization of less than 100 people as a sole IT person. As you start to scale up to large organizations, you'll also need to level up your knowledge of systems administration. You need to pick up skills that allow you to automate workflows and manage configurations or computer settings automatically. Don't worry, we'll discuss how to do this in an upcoming course on IT automation. Right now, let's focus on systems administration in a small organization. In the next couple of lessons, we're going to talk in detail about the responsibilities of a sysadmin and how that relates to a role of an IT support specialist who handles system administration. Basically, a sysadmin is responsible for their company's IT services. Employees need these IT services so that they can be productive. This includes things like email, file storage, running a website, and more. These services have to be stored somewhere. They don't just appear out of nowhere. Any thoughts on where they're stored? If you answer servers, you're correct. We talked about servers in an earlier course, and you've learned that the term servers can have multiple meanings. In one course, we discussed how servers have web content that they serve to other computers. In another course, we talked about how servers can be software that perform a certain function. In this video, we're going to talk about servers more in depth, because in many cases, sysadmins are responsible for maintaining all of the company's servers. If you're working as an IT support specialist and have systems administration responsibilities, these tasks could be something you'll perform. A server is essentially software or a machine that provides services to other software or machines. For example, a web server stores and serves content to clients through the internet. You can access the web server through a domain name like google.com. We'll dive deeper into web servers in a later course. Right now, let's run down some other examples of servers. An email server provides email services to other machines, and an SSH server provides SSH services to other machines, and so on and so forth. We call them machines that use the services provided by a server clients. Clients request the services from a server, and in turn, the servers respond with these services. A server can provide services to multiple clients at once, and a client can use multiple servers. Any computer can be a server. I could start up a web server on my home computer that would be able to serve my own personal website on the internet for me. But I don't really want to do that because I'd have to leave my computer on all the time in order for my website to be available all the time. Industry standard servers are typically running 24/7, and they don't run on dinky little hardware like my home laptop. They run on a really powerful and reliable hardware. Server hardware can come in lots of different forms. They can be towers that sit upright that look very similar to the desktops we've seen. Those towers can be put in a closet or can sit on a table if you want them to. But what if you needed to have 10 servers? The towers would start taking up way too much space. Instead, you can use rack servers, which lay flat and are usually mounted in a 90-inch wide server rack. If you needed even more space, you could use blade servers that are even slimmer than racks. There are other types of form factors for servers, but these are the most common ones. You can also customize the hardware on your service depending on the services. For example, on a file server, you'll want more storage resources so that you can store more files. What about connecting to our servers? Working in a small IT organization, you could potentially deal with a handful of servers. You don't want to have a monitor, keyboard, and a mouse for each of these servers, do you? Fortunately, you don't have to, thanks to something we learned in an earlier course. We can remotely connect to them with something like SSH. Even so, you should always have a monitor keyboard on hand. Sometimes when you're working, your network might be having issues and SSH won't be an option. A common industry practice is to use something known as a KVM switch. KVM stands for keyboard, video, and mouse. A KVM switch looks like a hub that you can connect multiple computers to and control them using one keyboard, mouse, and monitor. You can read more about using KVMs in the next supplemental reading. Okay, now that we've got a better understanding of servers and what they do, you can go out and start buying server hardware and setting up services for your organization. Or maybe not. You don't actually have to buy your own server hardware or even maintain your own services. In the next video, we're going to learn about a wave of computing that's starting to overtake the IT world, cloud computing. See you there. Oh, the cloud. The magical, wonderful cloud that you hear about in the news that moves data across the white, fluffy wonders in the sky. The magical cloud disperses bits of data across in the world in itty-bitty raindrops, right? No, that's not how the cloud works at all. But you'd be surprised how many people believe that. There's no doubt you've heard the term cloud in the news or from other people. Your photos are stored in the cloud. Your email is stored in the cloud. Cloud computing is the concept that you can access your data, use applications, store files, etc. from anywhere in the world, as long as you have an internet connection. But the cloud isn't a magical thing. It's just a network of servers that store and process our data. You might have heard the word data center before. A data center is a facility that stores hundreds, if not thousands, of servers. Companies with large amounts of data have to keep their information stored in places like data centers. Large companies like Google and Facebook usually own their own data centers because they have billions of users that need access to their data at all times. Smaller companies could do this, but usually rent out parts of a data center for their needs. When you use a cloud service, this data is typically stored in a data center or multiple data centers. Anywhere that's large enough to hold the information of millions, maybe even billions of users. It's easy to see why the cloud has become a popular way of computing in the last few years. Now, instead of holding onto terabytes of storage space on your laptop, you can upload that data to a file storage service like Dropbox, which stores that data in a managed location like a data center. The same goes for your organization. Instead of managing your own servers, you can use internet services that handle everything for you, including security updates, server hardware, routine software updates, and more. But with each of these options come a few drawbacks. The first is cost. When you buy a server, you pay upfront for the hardware. That way, you can set up your services, like a file storage, at potentially very little cost because you're the one managing it. When you use internet services like Box, Dropbox, that offer file storage online, the starting cost may be smaller, but in the long term, costs could add up since you're paying a fixed amount every month. When comparing the cost of services, always keep in mind what a subscription could cost you for every user in your organization. Weigh that against maintaining your own hardware in the long term, and then make the decision that works best for your organization. The second drawback is dependency. Your data is beholden to these platforms. If there's an issue with the service, someone other than you is responsible for getting it up and running again. That could cost your company precious loss of productivity and data. No matter what method you choose, remember that you're still responsible for the problems that arise when there's an issue. If Dropbox is having an issue with your important user data, it's still your problem, and you have to get it working again, no matter what. To prevent a situation like that from popping up, you might consider backing up some critical data in the cloud and on a physical disk. That way, if one system goes down, you have another way to solve the problem. Whether you choose to maintain physical servers or use cloud services, these are the type of things you need to think about when providing services to your company. In the next couple of lessons, we're going to talk about some of the other responsibilities of a sysadmin. We'll give you a high-level overview of these, then dive even deeper later in this course. In a small company, it's usually a sysadmin's responsibility to decide what computer policies to use. In larger companies with hundreds of employees or more, this responsibility usually falls under the chief security officer. But in smaller businesses or shops, as the IT lingo goes, the sysadmin has to think carefully about computer security and whether or not to allow access to certain users. There are a few common policy questions that come up in most IT settings that you should know. Should users be allowed to install software? Probably not. You could run the risk of having a user accidentally install malicious software, which we'll learn about in the upcoming course in security. Should users have complex passwords with certain requirements? It's definitely a good rule of thumb to create a complex password that has symbols, random numbers, and letters. A good guideline for a password length is to make sure it has a minimum of 8 characters that make it more difficult for someone to crack. Should users be able to view non-work related websites like Facebook? That's a personal call. Some organizations prefer that their employees only use their work computer and network strictly for business. But many allow other users so their employee can promote their business or goods on social media platforms, stay up to date on current events, and so on. It will definitely be a policy that you and your organization's leaders can work out together. If you hand out a company phone to an employee, should you set a device password? Absolutely. People lose their mobile devices all the time. If a device is lost or stolen, it should be password protected, at the very least, so that someone else can't easily view company emails. We'll dive way deeper into the broader impact and implications of security and organizational policies in the security course that's last up in this program. These are just a few of the policy questions that can come up. Whatever policies are decided upon have to be documented somewhere. As you know from our lesson on documentation in the first course, it's super critical to maintain good documentation. If you're managing systems, you'll be responsible for documenting your company's policies, routine procedures, and more. You can store this documentation on an internal wiki site, file server, software, wherever. The takeaway here is that having documentation of policies readily available to your employees will help them learn and maintain those policies. We've talked a little bit about the services that are potentially used in an organization, like file storage, email, web content, etc. But there are many other infrastructure services that you need to be aware of. As an IT support specialist doing system administration, you'd be responsible for the IT infrastructure services in your organization. Spoiler alert, there are a lot of them ahead. As always, make sure to rewatch any lessons if you need some more time for the material to sink in. Rome wasn't built in a day, and neither are IT support specialists. So, how about getting network access? That's a service that needs to be managed. What about secure connection to websites and other computers? You guessed it. That's also a service that has to be managed. And managing services doesn't just mean setting them up. They have to be updated routinely, patched for security holes, and compatible with the computer within your organization. Later in this course, we'll dive deeper into the essential infrastructure services that you might see in an IT support specialist role. Another responsibility sysadmins have is managing users and hardware. Sysadmins have to be able to create new users and give them access to their company's resources. On the flip side of that, they also have to remove users from an IT infrastructure if users leave the company. It's not just user accounts they have to worry about. Sysadmins are also responsible for user machines. They have to make sure a user is able to log in and that the computer has the necessary software that a user needs to be productive. Sysadmins also have to ensure that the hardware they're provisioning or setting up for users is standardized in some way. We talked in an earlier course about imaging a machine with the same image. This practice is industry standard with dealing with multiple user environments. Not only do sysadmins have to standardize settings on a machine, they have to figure out the hardware lifecycle of a machine. They often think of the hardware lifecycle of a machine in a literal way. When was it built? When was it first used? Did the organization buy it brand new or was it used? Who maintained it before? How many users have used it in the current organization? What happens to this machine if someone needs a new one? These are all good questions to ask when thinking about an organization's technology. Sysadmins don't want to keep a 10-year-old computer in their organization. Or maybe they do. Even that's something they might have to make a decision on. There are four main stages of the hardware lifecycle. Procurement. This is the stage where hardware is purchased or reused for an employee. Deployment. This is where hardware is set up so that the employee can do their job. Maintenance. This is the stage where software is updated and hardware issues are fixed if and when they occur. Retirement. In this final stage, hardware becomes unusable or no longer needed, and it needs to be properly removed from the fleet. In a small organization, a typical hardware lifecycle might go something like this. First, a new employee is hired by the company. Human resources tells you to provision a computer for them and set up their user account. Next, you allocate a computer you have from your inventory, or you order a new one if you need it. When you allocate hardware, you may need to tag the machine with a sticker so that you can keep track of which inventory belongs to the organization. Next, you image the computer with a base image, preferably using a streamlined method that we discussed in our last course, Operating Systems in U. Next, you name the computer with a standardized host name. This helps with managing machines. More on that when we talk about directory services later. In regards to the name itself, we talked about using a format such as username-location, but other hostname standards can be used. Check out the supplemental reading to find out more. After that, you install software the user needs on their machine. Then, the new employee starts and you streamline the setup process for them by providing instructions on how to log into their new machine, get email, etc. Eventually, if a computer sees a hardware issue or failure, you look into it and think through the next steps. If it's getting too old, you'll have to figure out where to recycle it and where to get new hardware. Finally, if a user leaves the company, you'll also have to remove their access from IT resources and wipe the machine, so that you can eventually reallocate it to someone else. Imaging. Installing software and configuring settings on a new computer can get a little time-consuming. In a small company, you don't do it often enough where it makes much of a difference. But in a larger company, a time-consuming process just won't cut it. You'll have to learn automated ways to provision new machines so that you only spend minutes on this and not hours. Luckily for you, we discuss how to do this in the next course of IT automation. See, we got you covered. When you manage machines for a company, you don't just set it and forget it. You have to constantly provide updates and maintenance so that they run the latest secure software. When you have to do this for a fleet of machines, you don't want to immediately install updates as they come in. That would be way too time consuming. Instead, to effectively update and manage hardware, you do something called batch update. This means that once every month or so, you update all your servers with the latest security patches. You have to find time to take their services offline, perform the update, and verify that the new update works with the service. You also don't have to perform an update every single time a new software becomes available, but it's common practice to do batch updates for security updates and very critical system updates. In the security course, we dive deeper into security practices, but a good guideline is to keep your system secure by installing the latest security patches routinely. Staying on top of your security is always a good idea. Not only do sysadmins in a small company work with users and computers, they also have to deal with printers and phones too. Whether your employees have cell phones or desk phones, their phone lines have to be set up. Printers are still used in companies, which means they have to be set up so employees can use them. Sysadmins might be responsible for making sure printers are working, or if renting a commercial printer, they have to make sure that someone can be on site to fix it. What if a company's fax machine isn't working? If you don't know what a fax machine is, that's not totally surprising. They've been slowly dying since the invention of email. Fax machines are still alive and kicking at companies, and they're a big pain to deal with. Sysadmins could be responsible for those too. Video audio conferencing machines. Yep, they'll probably need to handle those too. In an enterprise setting, sysadmins have to procure this hardware one way or another. Working with vendors or other businesses to buy hardware is a common practice. Setting up businesses' accounts with vendors like Hewlett-Packard, Dell, Apple, etc. is usually beneficial since these companies can offer discounts to businesses. These are things that sysadmins have to think about. It's typically not scalable just to go out and purchase devices on Amazon, although if that's what's decided, they could do that too. Sysadmins must be sure to weigh their option before purchasing anything. They need to think about hardware supply. So, if a certain laptop model isn't used anymore, they need to think of a suitable backup that works with their organization. Price is also something to keep in mind. They will probably need formal approval from their manager or another leader to establish this relationship with a vendor. It's not just technical implementations of hardware that sysadmins have to consider. It's so many things. We talked about troubleshooting a lot in an earlier course, but it's worth mentioning again. When you're managing an entire IT infrastructure, you'll constantly have to troubleshoot problems and find solutions for your IT needs. This will probably take up most of your time as an IT support specialist. This could involve a single client machine from an employee or a server or service that isn't behaving normally. Some folks who start their careers in IT support deepen their knowledge to become system administrators. They go from working on one machine to multiple machines. For me, I made the leap during my internship as an IT support specialist in college at a semiconductor lab. The lab ended up closing and they needed help deprecating the environment. So what started as an IT help desk support quickly transitioned to a sysadmin role. That opportunity was my golden ticket to dabble into Active Directory, subnetting, and decision making, which is a core part of this job. Sysadmins also have to troubleshoot and prioritize issues at a larger scale. If a server that sysadmin managed stopped providing services to 1,000 users and one person had an issue about the printer, which do you think would have to be worked on first? Whatever the scenario, there are two skills that are critical to arriving at a good solution for your users. And we already covered them in an earlier course. Do you know what they are? The first is troubleshooting, asking questions, isolating the problem, following the cookie crumbs, and reading logs are the best ways to figure out the issue. You might have to read logs from multiple machines or even for the entire network. We talked about centralized logging a little bit in the last course on operating systems and you. Becoming a power user. If you need a refresher to how centralized logging works, check out the supplemental reading. Anyway, the second super important skill that we covered is customer service. Showing empathy, using the right tone of voice, and dealing well with difficult situations. These skills are essential to all IT roles. In some companies, sysadmins have to be available around the clock. If a server or network goes down in the middle of the night, someone has to be available to get it working again. Don't worry, a sysadmin doesn't have to be awake and available 24/7. They can monitor their service and have it alert them in case of a problem. We'll discuss service monitoring in detail in the next course, IT automation. So how do you keep track of your troubleshooting? A common industry standard is to use some sort of ticketing or bug system. This is where users can request help on an issue and then you can track your troubleshooting work through the ticketing system. This helps you organize and prioritize issues and document troubleshooting steps. Throughout this course, we'll introduce types of services that a sysadmin needs to maintain and what responsibilities they have in an organization. We'll also share some best practices for troubleshooting when it comes to systems administration. When you work as an IT support specialist, systems administration can become part of your job, so it helps to think about all aspects of managing an IT infrastructure in an organization. The more prepared you are, the better. Let's take a bit of a dark turn and talk about disasters. Like it or not, something at some point will start working, no matter how much planning you do. This happens in both small and large companies. It's an equal opportunity problem. You can't account for everything, but you can be prepared to recover from it. How? It's super important to make sure that your company's data is routinely backed up somewhere, preferably far away from its current location. What if a tornado struck your building and your backups got swept away with it? You wouldn't have a building to work in, let alone be able to recover your data and get people up and running again. Later in this course, we'll talk more about what methods you can use to back up your organization's data and to recover from a disaster. We'll try to keep things a little lighter in the meantime. So far, you've learned a lot about the roles and responsibilities of a sysadmin. Some of it may seem like a lot of work, some might even seem scary. Being responsible for keeping data available isn't easy, but it's a rewarding role in IT. And you're already building your SA or sysadmin skill set by learning the fundamentals of IT support. Next up, we've got a quiz for you. Then in the next module, we'll discuss the technical details of the infrastructure services used in IT. See you there.
My name is Dion Paul, and I am an operations specialist with the GTech risk team. GTech stands for Google Technical Services. I wasn't always too familiar with IT, but one misconception is that you can know enough. And what I found out is that you can never know enough. There's never a threshold of learning. Things are always going to be changing, especially in IT, so it is very important to keep learning, keeping abreast of the latest technologies, wherever it leads me to. I'm never going to stop learning, and I'm always going to be open to learning new things and applying those in different ways. My most memorable career moment was actually getting to meet the former First Lady Michelle Obama during a work trip. I was selected to participate in a project at the White House based on the work that my team was doing, and we were able to not only engage her in a virtual reality shoot, but I also was tasked with ensuring that all the equipment was working, placing it directly in front of her, meeting her, and the content was going to be rolled out to millions of kids around the world, being able to operate a camera with the First Lady right in front of me, which is a moment I won't ever forget. Success to me is a journey, and I define it as just peace. Just being at peace with your work career, being at peace with your family, whatever that means to you, whatever that personally means. I like being able to have some quiet time on the weekends outside of work to spend with my family and stuff. At work is being involved in projects that you're passionate about and feel like you're contributing to just agree to a thing. But to me, success is a journey, and to me it's defined as just being at peace with whatever you're working at.
Welcome back. In the last module, we learned that system administrators have lots of responsibilities, like maintaining infrastructure services. IT infrastructure services are what allow an organization to function. These include connecting to the internet, managing networks by setting up the network hardware, connecting computers to an internal network, etc. In this lesson, we're going to learn about the common IT infrastructure services out there and what you need to know to start integrating them into an organization. We'll also dig deeper into each infrastructure service individually. We will focus more on the physical infrastructure services like servers, along with network infrastructure services that keep your company connected to the internet. In short, we'll be servicing all your infrastructure services needs. There are lots of IT infrastructure services that keep a company running. In a smaller company, a single person could be responsible for all these services. In larger companies, teams of sysadmins might manage just one service. In this course, we're going to discuss what you'll need to set up these services as the sole IT person in a company. We'll also give you an overview of some of the cloud services that you can utilize if you wanted another company to run your services. Reminder, as we mentioned before, cloud services are services that are accessed through the internet, like Gmail. We can access our Gmail accounts from any computing device as long as we're connected to the internet. By the end of this module, you should be well versed in what services you'll need to have a functioning IT infrastructure for your company. There are lots of types of IT infrastructure services out there. We'll start by giving you a high-level overview of them in this lesson. Then we'll dive into the nitty-gritty details on how you configure and maintain these services in later lessons. Sounds good? Let's get started. We talked about physical infrastructure components of an IT environment in an earlier lesson. Remember that you can set up different servers to run your services on, like a server to run your file storage service. You can buy or rent hardware for these servers and set up and store them either on-site or at another location. Essentially, you manage these servers end-to-end. There's another option. If you don't want to be responsible for managing the hardware tasks and updating your server operating systems with security patches and updates, you can use the cloud alternative to maintain your own infrastructure, which is called Infrastructure as a Service, or IaaS. IaaS providers give you pre-configured virtual machines that you can use just as if you had a physical server. Some popular IaaS providers are Amazon Web Services and their Elastic Compute Cloud, or EC2 instances, Linode, which rents out virtual servers, Windows Azure, and Google Compute Engine, which you've been using throughout this course. You can read more about the different IaaS providers in the supplemental reading right after this video. Your company's internal network isn't going to be like your network at home. You're going to have multiple computers that need to be on a certain subnet. You have to assign them IP addresses statically or using DHCP. The networking hardware has to be set up. Wireless internet will probably need to be available. DNS needs to be working, etc. If your company is large, networking is usually taken care of by a dedicated team. But in smaller companies, you'll probably be responsible for setting up the network. Network can be integrated in an IaaS provider, but in recent years, it's also been branched off into its own cloud service, Networking as a Service, or NaaS. NaaS allows companies to offshore their networking services so that they don't have to deal with the expensive networking hardware. Companies also won't have to set up their own network security, manage their own routing, set up a WAN, and private intranets, and so on. For more about NaaS providers, check out the supplemental reading. Let's talk about the software that your company might want to use. Do you need to type out Word documents, use an email client, communicate with other people, use operating systems, process spreadsheets, or have any other software needed to run a business? I bet yes. The right software has to be available to your company's users. We've already discussed how to install and maintain software and machines. You have to deal with things like licenses, security, updates, and maintenance for each machine. The cloud alternative to maintaining your own software is known as Software as a Service, or SaaS. Instead of installing a word processor on every machine, you can use Microsoft Office 365 or Google's G Suite. These are both services that you can purchase that allow you to edit Word documents, process spreadsheets, make presentations, and more, all from a web browser. You can check out the next supplemental reading for more about SaaS providers. Some companies have a product built around a software application. In this case, there are some things that software developers need to be able to code, build, and ship their software. First, specific applications have to be installed for their programming development environment. Then, depending on the product, they might need a database to store information. Finally, if they're serving web content like a website, they'll need to publish their product on the internet. If you're building this entire pipeline yourself, you may need to set up a database and a web server. The programming development environment will also have to be installed on every machine that needs it. If you want an all-in-one solution to building and deploying a web application, you can use something called Platform as a Service, or PaaS. This includes an entire platform that allows you to build code, store information in a database, and serve your application from a single platform. Popular options for PaaS are Heroku, Windows Azure, and Google App Engine. As you might have guessed, you can read more about PaaS providers in the supplemental reading. The last IT infrastructure service we'll discuss is the management of users, access, and authorization. A directory service centralizes your organization's users and computers in one location so that you can add, update, and remove users and computers. Some popular directory services that you can set up are Windows Active Directory, OpenLDAP, and we'll dive a little deeper into both of these later on in this course. Directory services can also be deployed in the cloud using Directory as a Service, or DaaS providers. Guess where you can read more about DaaS providers? That's right, in the supplemental reading. There you have it. There's a general overview of the most common IT infrastructure services you'll encounter when handling system administration tasks. While cloud services are a great option, it's super important that you understand how a service works and how to maintain before you employ the help of a cloud service. Even though cloud services are widely used in the industry and have a lot of pros, there are also some cons. These include recurring cost and the need to depend on the provider's service. We're going to teach you about the technical details and the implementation of these common IT infrastructure services. We'll cover everything from setting up your own server and figuring out which applications you need to be productive to how to set up multiple users and get your network services in order. By the end of this course, you have the foundational knowledge required to set up the IT infrastructure for a small organization.
I grew up in a small town in the desert, and there wasn't really much to do except read, play with computers, and study. And this is where I really learned to love technology, to understand how this computer worked, how it did what it did, and how I could make it do something different. And when I went to college, I began to study the Unix operating system. And I learned just enough to get an internship at the local ISP. And this was quite alarming for me because the first day of my internship, I walked in and they said, "Great, we're so happy you're here. You know Unix, right?" "Yes." "Here's a Radius server. We want you to set it up. It needs to be done by the end of the week." And I said, "How exciting. I get to do something that will have an impact on our users and I will get to learn something." There was just one problem. I didn't know what Radius was. So this was going to be quite a difficult challenge for me. So I had to read the manuals, the man pages, and I had to scour the library for books. And it took me about 3 days to learn what Radius was and how to set it up. But in the end, I knew more about it than anyone else at the ISP. And that expertise really, I think, drove me to become an expert in more areas. It gave me a lot of confidence that I could do that work, and it was actually really invigorating. And so I ended up as a Unix sysadmin and sort of went from there.
When you want to set up a server, you essentially install a service or application on that server like a file storage service. Then that server will provide those services to the machines that request it. Maybe you thought you'd install services on a user operating system like Windows 10. While that's an option, typically in an organization, you'll want to install your services on a server operating system. Server operating systems are regular operating systems that are optimized for server functionality. This includes functions like allowing more network connections and more RAM capacity. Most operating systems have versions specifically made for servers. In Windows, you have Windows Server. In Linux, many distributions come with server counterparts like Ubuntu Server, which is optimized for server use. Mac OS is also available in Mac OS Server. Server operating systems are usually more secure and come with additional services already built in, so you don't have to set up these services separately. You can read more about the different server operating systems in the next supplemental reading. For now, just keep in mind that when you install services on a server, you should be sure to use a dedicated server operating system. We discussed virtual machines in the last course and covered how to set up a virtual machine on a personal computer. In this lesson, we're going to talk about why virtualization can be an important part of infrastructure services and systems administration. There are two ways you can run your services, either on dedicated hardware or on a virtualized instance on a server. When you virtualize a server, you're putting lots of virtual instances on one server. Each instance contains a service. There are a bunch of pros and cons to running your services on either of these platforms. Here's the rundown. Performance. A service running on a dedicated hardware will have better performance than service running in a virtualized environment. This is because you only have one service using one machine, as opposed to many services using one machine. Cost. Server hardware can be pretty expensive. If you put a service on one piece of dedicated hardware and have to do that for 9 other services, it starts to add up. One of the huge benefits to virtualizing your servers is that you can have 10 services running on 10 different virtual instances, all on one physical server. Here's another way to think about this. In a typical server, if you only have one service running, it's probably only taking up 10 to 20% of your CPU utilization. The rest of the hardware isn't being utilized. You could add plenty more services to the physical server and still have a good threshold for resource utilization. It's cheaper to run several services on one machine than it is to run many services on multiple machines. Maintenance. Servers require hardware maintenance and routine operating system updates. Sometimes you need to take the service offline to do that maintenance. With virtualized servers, you can quickly stop your service or migrate them to another physical server, then take as much time as you need for maintenance. Virtualized servers make server maintenance much easier to do. Points of failure. When you put a service on one physical machine and that machine has issues, you're entering a world of trouble. With virtualized servers, you can easily move services off a physical machine and spin up the same service on a different machine as a backup. You could also do this with a physical server, but that could become costly if you account for multiple servers. Pro tip, you can prevent a single point of failure on a physical machine if you have a redundant servers set up, meaning you have duplicate servers as a backup. You'll learn about backups in an upcoming module. As you can see, there are lots of benefits to using virtualized servers. Just make sure to weigh the pros and cons of virtualizing your servers and using dedicated server hardware. That way, you can make the right choice for your company. Another important part of physical infrastructure services is the ability to connect to your infrastructure from anywhere in the world. We talked about remote access in an earlier course, and we've been using it all throughout this program to connect to our lab machines. In this lesson, we're going to discuss what's needed to set up for remote access for a small organization. As a systems administrator or as anyone in IT support, you'll want to be able to remotely access another server or user's machine so that you can troubleshoot an issue or do maintenance from wherever you may be. In Linux, the most popular remote access tool is OpenSSH. We've already learned how to SSH into a remote computer in the last course, and we talked a bit about what's needed to set up SSH, but we'll quickly show you how to do this. To SSH into another machine, you need to install an SSH client on the machine you're connecting from. Then install an SSH server on the machine you're connecting to. To learn more about OpenSSH, you can check out the next supplementary reading. But let's keep rocking and rolling with how to install the OpenSSH client on a machine. It's super easy. What you're going to do is I'm going to go to my client machine and simply run this command, sudo apt-get install OpenSSH client. And so downloading the package. And perfect. So it looks like my client has been installed. Next, you need to install the OpenSSH server on the machine you want to access. Remember, the SSH server is just a process that listens for incoming SSH connections. So let's go to the server and install the OpenSSH server. So I'm going to do sudo apt-get install OpenSSH server. Perfect. So it looks like my server is up and running. So let's go back to the client and do a test. I do SSH. Enter my server IP address with my username. So ask for my password, which is a good thing. Perfect. So as you can see, I'm connected to my server, and one true way to test this is if I go into my desktop of my server, and let me create a folder. Now if I go back to my server, which is on this window, I list the files, you can see the folder test, and that's it. Now you're able to SSH into a machine from another machine. Not too complicated, right? Windows has similar tools that you can use. A popular tool to access the CLI remotely is WinRM or PuTTY. RDP is also popular if you want to access the GUI remotely. We've already discussed how to connect to a machine using PuTTY in the last course. Just remember to install an SSH server on the machine you want to connect to. We also already discussed how to set up RDP in the last course. Feel free to review those lessons as a refresher. You can read more about the Windows Remote Access tools in the next reading. The takeaway here is that when you manage IT infrastructure, you can utilize tools like remote access to work on your physical infrastructure. You'll need to do a little bit of setup beforehand, like installing the SSH client, SSH servers, and allowing remote desktop connections, etc. But it'll be worth it in the long run. Next up, we'll tackle network service. See you there. Now that we're a little more familiar with some of the common aspects of physical infrastructure, let's move on to network services. A network service that's commonly used in an organization is a file transfer service. So, why would you want to have a service dedicated to file transfer? Well, sure, you could probably carry around a flash drive and copy files to each machine you work on, or even use the remote copy tools we learned in the last course. Or you could centrally store your files and transfer files from one computer to another using the internet. There are a few different file transfer protocol services that are used today. Let's take a quick rundown of what's out there and what they do. FTP. In the second course of this program, the bits and bytes of computer networking, we mentioned FTP, aka the file transfer protocol. It's a legacy way to transfer files from one computer to another over the internet, and it's still in use today. It's not a super secure way to transfer data because it doesn't handle data encryption. The FTP service works much like our SSH service. Clients that want to access an FTP server have to install an FTP client. On the FTP server, we install the software that allows us to share information located in a directory on that server. FTP is primarily used today to share web content. If you use a website host provider, you might see that they have an FTP connection already available for use, so they can easily copy files to and from your website. SFTP is a secure version of FTP, so it makes sense to choose this option over FTP. During this SFTP process, data is sent through SSH and is encrypted. TFTP stands for Trivial FTP. It's a simpler way to transfer files than using FTP. TFTP doesn't require user authentication like FTP, so any files that you store here should be generic and not need to be secure. A popular use of TFTP is to host installation files. One method of booting a computer that we haven't discussed yet is PXE or Pixie boot, which stands for Preboot Execution. This allows you to boot into software that's available over the network. A common use case for organizations that want to install software over a network is to keep operating system installation files on a TFTP server. That way, when you perform a network boot, you can be automatically launched into the installer. This is a lot more efficient than having to carry around a USB with an operating system image. You can learn more about Pixie boot in the next reading. Depending on your usage of file transferring services, you might want to weigh the option we mentioned. We encourage you to read about popular FTP clients used in the supplemental reading. If you just want to share files between your computers in a secure way and have a nice directory where you can access all the shared files instead of transferring them to your machine, you'll want to look at network file storage services instead. We'll discuss those in an upcoming module. One of the oldest internet protocols in use today is the Network Time Protocol, or NTP. It's used to keep the clock synchronized on machines connected to a network. You've probably seen NTP implemented in your personal life if you've ever been in an airport. Airports utilize synchronized clock systems, and many of their systems use NTP. This is because the information that you see on your departure and arrival screen has to match the time that the air traffic controller team sees for their airplanes. If only NTP could solve for airport delays. Anyway, in the IT world, machines need to have accurate time across the network for a lot of reasons. There are some security services like Kerberos, a network authentication protocol, that depend on the time being consistent across the network to work. You'll learn more about that in the IT security course coming up. It is important to keep the time consistent and accurate across your company's fleet. You can't depend on the hardware itself to keep consistent time, so you might want to set up an NTP server. There are different ways that an IT support specialist or sysadmin can do this for an organization. You can use a local NTP server or a public NTP server. To set up a local NTP server, you can install NTP server software on your managed server. Then you install NTP clients on your machines and tell those computers which NTP servers to sync their time to. This is a great option because you can then manage the entire process from end to end. The other way to set up NTP is to use a public NTP server. Public NTP servers are managed by other organizations that your client machines connect to in order to get synchronized time. This is an awesome way to utilize NTP without having to run a dedicated NTP server. But if you have a large fleet of thousands of machines, it's better etiquette to be running your own NTP servers. Another good practice is to run your own NTP server, then have that point to a public NTP server. This makes it so that you don't connect all your clients to a public NTP server and you don't have to manage the time synchronization. Whether you run your own NTP server or use a public one, NTP is an important network service that you should definitely integrate into your own fleet. There are a few network services that are used internally in an IT enterprise environment to improve employee productivity, privacy, and security. While they're pretty common, you might not encounter them in small organizations. We discussed these services in Course 2 on networking, but let's do a refresher. We're sure that you'll encounter them at some point in your IT career. There are intranets and proxy servers. An intranet is an internal network inside a company. It's accessible if you're on a company's network. Intranets can provide a wide range of information and are meant to improve productivity by giving employees a greater medium to share information. Think of it like the company's website that's only accessible to people on the company network. On this site, documentation can be centrally located, teams can post news updates, employees can write to forums and start discussions, and more. Intranets are most commonly seen in large enterprises and can be an incredibly valuable tool for employee productivity. Another internal support service that's widely used is a proxy server. Proxy servers act as an intermediary between a company's network and the internet. They receive network traffic and relay that information to the company network. This way, company network traffic is kept private from the internet. The internet gets traffic through a proxy server, but it doesn't know where it originally came from. It only knows the proxy. Proxy servers can also be used to monitor and log internal company network activity. They can be configured so certain websites are filtered from being accessed. Proxy servers are useful for providing privacy and security on the internet and regulating access inside a company. In the next few lessons, we'll talk about what are probably the most essential network services, DNS and DHCP. We did a deep dive on DNS, or Domain Name System, in the networking course. If you need a refresher on it, make sure to review the material there. As a super quick recap, DNS is what maps human understandable names to IP addresses. It's an important network service to set up and maintain when managing a company's IT infrastructure. If you don't set it up correctly, no one will be able to access websites by their names. We don't really have to think about DNS on our personal computers. When you connect a brand new machine to the internet and start typing in a web address, it just works automatically. You don't have to type in IP address or anything, but something is happening in the background. When you connect to a network, you're using the DNS server address that was provided by the router you connected to. It updates your network setting to use that DNS server address, which is usually your ISP's DNS server. From there, you're able to access pretty much any website. So why do you need to set up your own DNS servers if DNS just works out of the box? Well, there's two reasons. First, if you're running a web service like a website, you want to be able to tell the internet what IP address to reach your website at. To do that, you need to set up DNS. The second reason is that you probably want to work on your server or user machines remotely. In theory, you could remote access into them through an IP address, but you could also just use an easy-to-remember hostname. To do that, you need DNS to map the IP address to the hostname. In the next couple of lessons, we'll discuss what's needed for DNS setup for websites and internal networks. You might remember that we can use a web server to store and serve content to clients that request our services. We'll probably want to store website content on our web server. If clients want to reach our website, we need to set up DNS so that they can just type a URL to find us. So let's talk about how DNS gets set up for a website. First, we need a domain name. We can buy a domain name like settingupdnsisfun.example.com. We can purchase domain names like this from companies called domain registrars, like GoDaddy.com or Bluehost.com. Once we have our domain name, we want to point our website files to this domain name. Our website files can be stored on a cloud hosting provider, or we can decide to control this ourselves and store it on our own servers. Typically, domain registrars also provide cloud hosting services, but they can charge you a monthly fee to host your web files for you. Pro tip, if you don't want to utilize cloud hosting services, you can just run your own web server. Don't forget, there are always pros and cons to hosting a service yourself or offshoring it somewhere else. So if you're the sole IT support specialist for an organization, make sure to weigh all your options before committing to an infrastructure service. Let's assume that we do want to host our website files ourselves. From here, we still need to point our new domain name to where our web content is located. We can do this in two ways. Most domain registrars can provide you with DNS settings, and you can give the IP address of where your content is stored. If you decide not to use your domain registrar to host DNS for you, then you have to set up an authoritative DNS server for your website. Remember from our discussion in Course 2 that authoritative DNS servers are the DNS servers that know exactly what the IP address is for the domain name? Since we own the domain name and host our web content ourselves, it makes sense for us to have the DNS servers that know that information. The other reason we might want our own DNS servers is so we can map our internal computers to IP addresses. That way, we can reference a computer by name instead of IP address. There are a few ways we can do this. One is using a local host file which contains static IP addresses to hostname mappings. Let's take a look at an example of this. Remember that we learned that host files in networking allows us to map IP addresses to hostnames manually. In Linux, our host file is called etc/hosts. It has an IP address that points to 127.0.0.1, which points to a name called localhost. This just references back to the computer. Localhost is commonly used as a way to access a local web server. We'll talk about web servers in an upcoming module. So for now, let's not worry too much about localhost. Instead, if I change this IP address mapping to www.google.com, then save and open a web browser and type www.google.com, it won't take me there. Let me show you that. So I'm going to go ahead and change my localhost to www.google.com. I'm going to save this, open my web browser to www.google.com, and as you can see, it didn't take me anywhere. It just takes me back to my local computer. This is because a DNS query first checks our local host file, then our local DNS servers. So if there's an entry for google.com in my host file, it will go to that IP address instead. Let's say I wanted to access Natalie's computer at 192.168.1.5 and her host name is catlady.examplecompany.com. I would have to enter this in my host file for every single computer in my fleet. That's definitely not the scalable option. Okay, so what's our next choice? We can set up a local DNS server that contains all the organization's computer names mapped to their IP addresses. This is a more central storage location for this information. Then, we change our network settings for all our computers to use this DNS server instead of the one given to us by our ISP. Finally, let's look at one of the last DNS options we can use for an internal network. It can be integrated with a directory service which handles user and machine information in a central location like Active Directory and LDAP. Once we set up DNS and our directory service, it will automatically populate with machine to IP address mappings. So there's no need to enter this information in manually. We'll talk more about these directory services in a later module. And voila! That's an overview of why you need a DNS, along with your options for configuring them. We won't dive too deeply into the technical details of setting up a DNS server, but if you are interested in learning about which DNS software to use,
There are a few popular options like bind or power DNS. I bet you can guess where you can read more about them in the supplemental reading. One thing about DNS that we haven't discussed is what to do if we use something like DHCP, which doesn't use static IP addresses. Don't worry, we'll cover this in the next lesson. Another network service that will make your job in IT support easier is DHCP, or Dynamic Host Configuration Protocol. Need a refresher on DHCP? Just check out the DHCP lessons in the networking course. When managing IT infrastructure and you want to connect a computer on a network, you have two options. You can grant it a static IP address or give it a DHCP assigned IP address. When you use a static IP address, you have to keep track of every IP address you assign a computer and manually enter it in the network settings. If you enable DHCP, your computers will be leased an IP address from a DHCP server. They'll automatically get IP addresses and you don't have to worry about manually setting addresses. If you ever decide you need to expand your IP address range, you don't have to change anything on the client machines either. It just happens automatically. To configure a DHCP server, you'll need to figure out which IP range you can use to assign IP addresses. If you want to integrate with DNS, you'll need the address of your local DNS servers, what gateway you should assign, and the subnet mask that gets used. Once you install the DHCP server software, you have to configure the settings with this information. Different DHCP server software manufacturers have different configuration setting layouts, so you'll have to investigate the specific one you want to use. There are a lot of popular DHCP server software you can use for this. Windows Server versions come with DHCP service built in, but you can read more about the options in the next reading. Once you turn on your DHCP server and your clients are set to receive DHCP addresses instead of static IP addresses, you should have working DHCP settings. In the last lesson, we talked about how DNS ties in with DHCP. Well, in our DHCP configuration settings, we can specify DNS server locations. The two servers then sync up, and when DHCP leases out new addresses, DNS updates its IP address mappings automatically. That's a super quick overview how DHCP servers are configured. Hopefully, you can now see why DHCP and DNS are critical network services for your organization. There will be times when you're working in an IT support role and you won't be able to resolve or get the IP address of a website name. This particular problem could be tricky to identify when you see it. You might just think that your network connection isn't working. Let's go ahead and try to navigate to google.com from my web browser. So let me get to my web browser and navigate to google.com. Oh, it doesn't look like we can get to google.com. Let's go over some of the tools that we learned in our networking class that can help. First up, if you're unable to resolve a domain name, check that your network connection is actually working. You can do a quick check and ping a website that you know is available. An oldie but goodie is to ping www.google.com. It's pretty rare that Google will be down, although it can happen. So let me go into my terminal and type in ping www.google.com. Looks like we're getting responses. Let's move on to isolating another problem, DNS. To verify that your DNS server is giving you a correct address for google.com, you can use NSLookup. Remember that NSLookup gives us the name server of a host or domain name. So let me go ahead and do that on my terminal. From here, we can rule out if DNS is an issue by verifying that the host name points to a named server. If we copy the IP address of the result and paste it into the web browser, it should resolve the website name if DNS is working. Let's go ahead and do that. So I'm going to go ahead and copy the non-authoritative IP address. Open my web browser. Oh, so I see that's working. What's going on? Looks like my DNS settings aren't working correctly. Let's look at my ping results again. So I'm going to go ahead to my terminal and ping www.google.com. I see that it checks an IP address different from what I have here. If I go to this IP address, it doesn't take me anywhere. So I'm going to take this IP address, copy this, Remember that when a DNS query is performed, your computer first checks host file. Now, if I access my host file here, I can see that I have an entry for www.google.com, and it points to a fake IP address. If I remove this line right here where it says 127.1.1.3 and save that configuration file, and then restart my browser, if I type in www.google.com, there we go, we're there. And the correct DNS setting should be applied to www.google.com. There are some situations where DNS can be tricky to navigate since there can be many contributing factors. But as with any troubleshooting scenario, remember to keep isolating the problem down until you can get to a root cause. With time and experience, you'll learn a lot more about DNS and how to troubleshoot it in the real world. We've covered a lot of information in this module. You learned about all the overall services needed in an IT infrastructure. On top of that, you learned about physical infrastructure services like remote access and virtualization that help your organization run more efficiently. You even learned about essential networking services like DNS and DHCP, along with the overall picture of what's needed to set up DNS for an organization and why you'd want to do that. Now we're going to test you on all that learning. And don't forget, you can always go back and review the material again if you need to before you take the quiz. In the next module, we're going to cover two of the other IT infrastructure services, software and platform services. I'll see you there. Welcome back. In the last module, we learned about the physical infrastructure and network services that are used in an IT organization. In this lesson, we're going to discuss the other services that make up an IT infrastructure, the software and the platform services. Software services are the services that employees use that allow them to do their daily job functions. This can include applications like word processors, internet browsers, email clients, chat clients, and so on. Platform services provide a platform for developers to code, build and manage software applications. This way, developers don't have to deal with operating system maintenance and other services that are needed to use for the platform tools. When managing IT infrastructure, it's important that you implement software services for your users to enable their productivity. Depending on what type of company you may manage, you may also need to manage platform services for software developers. Software services include a wide range of functions. We'll cover the major ones here. First up is communication services, which enable employees in a company to talk to one another. Then, there's security services, which add a layer of security protection to our IT infrastructure. We'll also discuss user productivity services and some of the aspects of managing software in a business that you'll probably have to think about in your work. There's lots of software out there that's used for intercompany communication, like email or phone communication. These are important communication services, but in this video, we're only going to discuss software that's used in instant communication. Instant communication has drastically changed how we communicate in both our personal lives and in the workplace. We can have multiple conversations with different people in real time using chat applications. You probably use something like Facebook Messenger on your smartphones to chat with your friends. In a business setting, there are similar methods of instant communication. The first is Internet Channel Relay, or IRC, which is a protocol that's used for chat messages. IRC operates in a client-server model, so lots of IRC client software can be used to connect to an IRC server.
IRC was widely used in the 1990s as a way to facilitate all kinds of chats, group chats, individual chats, and more. It's not as widely used today, given the wave of social media instant chat messages, but if you're considering setting up an IRC, it is a free alternative to other chat applications. Paid-for options are another method of instant communication. There are a lot more sophisticated and advanced chat applications out there that offer enterprise support. A few popular options are HipChat and Slack. You can read more about these in the supplemental reading. There are also other communication protocols called OpenIM protocols that are widely used and integrated into different communication applications. One of the most popular communication protocol is XMPP, or Extensible Messaging and Presence Protocol. It's an open source protocol used in instant messaging applications and social networking services. XMPP is even used in Internet of Things applications, among other things. A few popular and free applications that use XMPP are Pigeon and Adium. Feel free to check out more about these alternatives in the supplemental reading right after this video. Instant communication is a fantastic tool you can use to promote team collaboration and efficiency. When managing an IT infrastructure, it should be one of the communication services that you consider implementing for your organization. They'll definitely thank you, maybe even over instant communication. One communication service that you're almost guaranteed to use today is email. We use email for a wide range of communication. In an enterprise setting, it's important for a sysadmin or a sole IT support specialist to be able to configure email services for the company. To do this, you need to have a domain name set up for your company that you can use as your email domain, like devon@example.com. When you send or receive email, you want to use this email address. There are two ways to set up email for a company. The first is to run your own managed server. Using this option, you set up the email server software on a server. Then you create a DNS record for your mail server. There are different DNS records. Remember that the A record is used for host names, but for email servers, we use MX for the mail exchange record. Email server setup can be one of the most complicated servers to set up for a sysadmin. You have to get the email to actually work, protect your email addresses from spam, filter out viruses, and more. If you'd like to learn more about setting up an email server, check out the next reading. An alternative approach to setting up your own email servers is to use an email service provider like Google Suite. These service providers allow you to create email inboxes and more by paying a monthly fee for every user in your organization. This ties you into the Gmail webmail client and allows you to access your email from anywhere, as long as you're connected to the internet. Whatever option you choose, you'll have to understand the differences between email protocols when you set up your email accounts. There are lots of email protocols out there, but we'll only do a rundown of the more common ones you'll hear about: POP3, IMAP, and SMTP. Post Office Protocol, or POP version 3, is an email protocol that downloads email from an email server onto your local device. It then deletes the email from your email server. If you want to retrieve your email through POP3, you can only view it from one device. There are a few reasons why you might want to use POP3 to get your email. If you need to keep your email storage under a certain quota, POP3 is a good way to maintain that storage limitation. Another benefit of POP3 is privacy. Your email can only be seen from your local device. If storage limitations and security are a concern for you, you might want to consider using POP3 over something like IMAP. Speaking of, IMAP, or Internet Message Access Protocol, allows you to download emails from your email server onto multiple devices. It keeps your messages on the email server. This email protocol is one of the more popular ways to retrieve email. Last up is Simple Mail Transfer Protocol, or SMTP, which is a protocol used for sending emails. While POP3 and IMAP and other protocols can be used to retrieve email, there's really only one email protocol for sending email, SMTP. So there are lots of different email protocols that can be implemented depending on the email software you choose. You can read more about them in the supplemental reading. Email service is critical for any organization. Companies need to be able to contact clients and business partners and communicate internally. If you work in an IT support specialist role where you're handling system administration tasks, you will need to weigh the pros and cons of a dedicated email server or a cloud email service. Decisions, decisions, decisions. In any organization, the software that employees need to do their job is the software that an IT support specialist managing IT infrastructure needs to provide. Depending on the organization, you might need to get your users things like software development programs, word processing, graphical editors, finance software, and so on. Whatever software you provide, there are different things to consider when using it in a commercial setting that might not have crossed your mind when you've used a similar software personally. Remember when we discussed software licensing in an earlier lesson? When you use software, you're doing so under the agreement of the developer's license. For example, when you use open source software, the license agreement usually says that it's free to use, share, and modify. When software is used as a consumer, agreements can say that only a specific person can use the software. In a business or commercial setting, most software distributors will have a separate agreement. In most cases, you can buy 10 licenses and any 10 people in your company can use it. If someone leaves the company or doesn't need the software anymore, you can take their license and give it to someone else in the company. When considering software licenses, it's important to review the terms and agreements, then move forward with whatever option works best for your company. Things get a little more complicated when it comes to cloud software services. You might have to deal with some of the same stipulations and also think through whether to purchase added features for businesses and enterprises, like dedicated customer support. Whatever method you use to provide software, whether it's installing software on every machine or utilizing cloud software services, there's one thing to keep in mind. Software used as a consumer won't be the same as software used as a business. The last software services that we'll discuss are security services. Security is super important to all organizations. It's integrated into pretty much all aspects of an IT infrastructure service. We'll dive deeper into this in the last course on IT security. For now, remember that there are lots of different security protocols that are put in place for all sorts of things, keeping data encrypted, authentication, etc. If you ever manage a web server that serves content to other users, you want to let them know that when they access your website, you're keeping their interaction with you as secure as possible. Let's say that you have an online bank account that you're logging into. The URL will most likely begin with an HTTPS. Remember that HTTP stands for Hypertext Transfer Protocol, which is used to format and transfer web content around the internet. When you enter in a URL, you notice that the HTTP comes before everything else. HTTPS, or Hypertext Transfer Protocol Secure, is a secure version of HTTP. It makes sure the communication your web browser has with the website is secured through encryption. HTTPS is also referred to as HTTP over TLS or HTTP over SSL. This is because there are two protocols that enable us to make our web servers secure. The first is Transport Layer Security Protocol, or TLS, which is the most popular way to keep communication secure over a network. TLS is widely used to keep web browsing secure, but it can be used in a lot of other applications too. We'll do a deep dive into the technical details of TLS in a later course. The second protocol is Secure Socket Layer Protocol, or SSL. It's a way of securing communication between a web server and client, but it's pretty old and insecure, so it's been deprecated in favor of TLS. You may still see its name being used to refer to the TLS protocol, like SSL/TLS. The two protocols are often used interchangeably. In fact, SSL version 3.0 was essentially TLS version 1.0, but TLS's new features and updates have made it more secure than SSL. So if you're managing an organization's website on a server, how do you enable TLS on the server so that the site can be using HTTPS? Well, you need to get a digital certificate of trust from an entity called a certificate authority. The certificate authority grants a certificate to your website saying that it trusts that you control the web server and verifies that you are who you say you are. Once it does that, you can install the certificate on your web server. That way, when users visit your site, they'll see the HTTPS in the URL instead of just HTTP. You will learn more about certificates and certificate authorities in an upcoming course. For now, think of certificates as a way to verify that something is trustworthy. Security is an integral part of IT, and it's not just the responsibility of security engineers. Everyone should be thinking about security, and all layers of your infrastructure should have a layer of security built upon them. There are lots of other security software that you could add to your IT infrastructure, which we'll dive into the last course. For now, it's a good idea to know the basics of keeping a web server secure with HTTPS.
Knowing what I know now, the advice I would give my younger self is to not be afraid to talk to people, because I'm very shy. And I think also, my imposter syndrome tells me, don't look stupid, right? Don't ask dumb questions, don't ask silly questions, don't ask questions at all. And I think what I would tell myself is, do your research, do your reading, teach yourself and educate yourself. Continue to do that, but it will speed up the process so much faster. If you can find somebody you trust to collaborate with, to learn with, and to really find that good mentor, so that as a student you always have somebody that you can lean on. I have imposter syndrome every time I walk in the door. Yeah, every morning. Gosh, I'm going to work at Google. I have a meeting with the following people. I can't believe I'm having a meeting with the following people. And again, I just try hard to focus on what I really want to get out of it, what I want the outcome to be. Because even if it goes spectacularly wrong, I'm still going to have learned something. Once you have a few past you, it's going to feel better. Right? And you're going to understand what the successes look like and how you get them. And you'll be able to repeat those patterns over and over again. But in the end, if you don't like doing that, or the outcomes don't sound interesting to you, find new outcomes, because you will eventually find that thing that really drives you and that you're passionate about.
In the operating systems course, we discussed files in depth and how we use and modify them on our OSs. In this lesson, we're going to run down some of the file services we can use that will allow us to be productive as an organization. Employees need to be able to share files with each other, whether that's to collaborate or exchange information. We talked about shared folders in Windows in the last course, but in this lesson, we're going to talk about more scalable and efficient ways to share data. Enter file storage services. File storage services allow us to centrally store files and manage access between files and groups. You can set up a file storage server that will let users access a shared directory to modify or add files, and much, much more. In the next lesson, we'll go into depth on two of the more popular ways you can use to manage, store, and share files over a network. The other way to maintain a file storage service is by using a cloud file storage provider. There are lots of providers that offer secure and easily managed file storage. You can read about some of the more popular ones in the supplemental reading. For now, let's see how to manage a file storage service ourselves. In the last course, we mentioned that very few file systems can be used across all major operating systems. FAT32 is a popular file system that's compatible with Windows, Linux, and Mac OSs. But it has severe limitations on the amount of data you can store on a volume. What happens if you have multiple users that want to share files between each other? Well, they need to store the files somewhere and they need to be able to retrieve the files over a network. Network File System, or NFS, allows us to do this. It's protocol that enables files to be shared over a network. The file system is compatible on all major operating systems. The easiest way to set up an NFS server is by using a Linux environment. You can install NFS server software, then modify the configuration files for the directories that you want to allow shared access to. Once you do that, the NFS service will be running in the background of the server. On each client machine that wants to access the server, you just mount the file system the way you would any other file system, except you'd use a host name instead of a physical disk device. From there, you can access the shared directory like you would any other folder on your computer. Check out the next supplementary reading for some examples of NFS server software you can configure for Linux. NFS is a good solution to file sharing within a network, but as with anything on a network, heavy usage will slow down the file system. While NFS works with all major operating systems, there are still interoperability issues with Windows. If your fleet consists mostly Windows machines, you might want to look at using something like Samba. Samba services are similar to NFS since you can centrally share and manage file services. Also, all major operating systems can use a Samba file share. The only reason you might want to consider Samba over NFS is because it works better with Windows operating systems. It also includes other services that can be integrated with your organization, like printer services. We'll talk about printer services in an upcoming lesson. One thing to note is that you may hear the term Samba or SMB. These two are different. SMB is the protocol that Samba implements. You can read more about SMB in the supplemental reading. Fun fact, when you create a Windows shared folder, it's actually using the SMB protocol. Samba itself is a software service suite used for file services, which you can also read more about in the supplemental reading. There are lots of other file storage services that you can use, and you can read more about them in, wait for it, the supplemental reading. A relatively affordable solution for file storage hardware is to use a network attached storage, or NAS, pronounced NAS, instead of setting up a dedicated server like you would other services. NASs are computers that are optimized for file storage. They usually come with an operating system that's stripped down in order just to serve files over a network. They also come with lots of storage space. Whatever method you choose, central file storage and management is an important part of IT infrastructure for any organization. I told you we'd cover printing services, and here we are. While our world is moving more and more into the digital space, there are still aspects of our lives that require good old-fashioned paper. Many organizations still use printers, and as an IT support specialist, you have to manage them as you would any other device. If you have a printer at home, you probably connect it directly to your computer. Maybe you even print over your home network through Wi-Fi. Some small organizations can get away with this type of printer management, but most larger organizations have lots of printers that need to be managed and large volumes of information that need to be printed. When managing printer IT infrastructure, you need to have a place to centrally manage all your printers. You'll probably be running commercial printers that also can report diagnostics information, like low toner levels. Along with managing printers centrally, you'll also need to be able to deploy printer driver software so that your users can print from their computers. There are a few different ways that printers can be managed. Setting them up really depends on how many printers you have and how many people are in your company. In a small company with less than 100 people, setting up 1 or 2 commercial printers should be more than enough. To set up a print server, all you have to do is install a print service on a server. Most server operating systems already come with the printer service readily available. For example, let's look at Windows. In the Windows Server operating system, there's a print and document services that can be enabled. All you have to do is add your network printer to this service and install the drivers for those printers. Nice and simple, right? In Linux, a common print server that's usually pre-installed on machines is CUPS, or Common Unix Printing System. Let me show you. Cups allows you to easily manage printers from a simple web URL. You can read more about both the Windows Print and document services and Cups in the next reading. When your print server is set up, you need to add the printer to the client machine. Just search by the printer server name, connect to the device, and start printing. There are lots of ways you can optimize this process. When you start learning about directory services, we'll take you through how to set rules up on machines so that the printer and their drivers are automatically installed on a client computer. Another way you can manage printers is by using a cloud service provider. This allows you to manage your printers through a web browser. It also lets your users print through a web browser, so no setup is involved on their machines. Printer setup is pretty easy to do. Most of it depends on what printer service you decide to go with. We've learned a lot about software services in our IT infrastructure, from importing communication services to security and now printing. Let's keep charging ahead. In the next lesson, we're going to discuss platform services. Platform services provide a platform for developers to completely build and deploy software applications without having to deal with OS maintenance, server hardware, networking, or other services that are needed to use the platform tools. A web server that we deploy our web applications to, or the development software that we use to code our applications, are both examples of platform services. In this day and age, most businesses have a digital presence, whether that's a website that promotes their business, or even a website that is their business. Businesses that run web services keep their services stored on a web server. A web server stores and serves content to clients through the internet. You can access web servers using a domain name like google.com. A web server itself stores web files and runs an HTTP service or HTTP server that processes HTTP requests. Remember that HTTP is how the web formats and transfers web pages. You can think of the web server as the physical server that stores web files and the HTTP server software. When your web browser makes a request to fetch a web page from a URL, it sends an HTTP request that gets processed by the HTTP server. Then, the HTTP server sends out an HTTP response with the content that you requested. There are a lot of popular HTTP server software out there, but the most widely used is the Apache HTTP server, most commonly referred to as Apache. Apache is free and open source. It helps serve a large percentage of web pages on the internet. Let's actually see how a web server serves content to the web. I'm going to install the Apache web server software on my Linux computer here. You don't have to understand the specifics of the setup. I just want you to see how easy it is to run a web service. So let me go ahead and install Apache. So I'm going to go ahead and do sudo apt-get install Apache 2 and then hit the flag yes to accept all my packages. Perfect. Now our web server service is running on our machine. We're actually able to start hosting web content. The machine that we're hosting our content on is, well, this machine right here. Remember that our computer has an IP address that's associated with itself, 127.0.0.1, or a host name of localhost. Localhost itself is reserved for this purpose, so it's not possible to get the domain name localhost. So now that we know our machine's location, let's enter it to the web browser. And here it is, our local web server content running on our machine. The files we see here come with the default Apache installation. But if we wanted to upload our own web content, we can just navigate to the directory where this is stored and replace it with our web content. Remember that since this content is hosted on our local machine, we will need to use DNS to let the world know that our web server exists. If you need a refresher on this, feel free to go back to the lesson on DNS services. That's a quick rundown of how web servers work. You can read more about Apache and other HTTP servers in the next supplemental reading. System administrators aren't responsible for creating the content that gets served, but they might be responsible for making sure that content is available. If you're an IT support specialist with a web service that needs to be managed, you should have a pretty good understanding of how it works. When you run a service that operates on the web, you need to have a web server that serves web pages to clients that request it, like we just covered. But you may also need to store information. Have you ever thought about what happens to your information when you create an account online for a website? Where do they store that info? Do they put it in a folder on a web server? If they do, you need to stop using that service immediately. Customer information, like news articles, videos, large amounts of text, image, or audio files generally get stored in a database. Databases allow us to store, query, filter, and manage large amounts of data. When you build a web product, you'll probably store the data in a database. Database servers consist of database software that's running that you're able to read and write from. Common database systems like MySQL and PostgreSQL are widely used in application and web development and data analytics. These database systems usually require knowledge of special languages or syntaxes to be able to parse and filter through large amounts of data. If you want to dig deeper into database systems, check out the next reading. Administrating and managing a database can be incredibly complex. Losing precious data could cost a company dearly. There's actually an entire job specialization within IT that deals with databases just like that, called database administrators. We won't talk about their role in this program, but if you're interested in learning more, you should know where to look, the supplemental reading. Web servers and servers in general are prone to breakage just like any other machine. Troubleshooting a web server could involve lots of different variables. We won't discuss a specific troubleshooting scenario in this lesson, but we'll talk about some easy troubleshooting tools you can use to diagnose a faulty web server or browser, called HTTP status codes. When we want to go to google.com, our browser is sending an HTTP request to the HTTP server on the web server. In turn, we get an HTTP response. Sometimes this response returns the content that we want. Almost all the time, it will return a status message of the response. HTTP status codes are codes or numbers that indicate some sort of error or info messages that occurred when trying to access a web resource. Knowing common HTTP status code comes in handy when you're troubleshooting a website error. They'll usually tell you useful information that can help you isolate the root cause. Here's a common HTTP status code you might recognize: the dreaded 404 not found. A 404 error indicates that the URL you entered doesn't point to anything. Let's see what happens if I type in google.com/ASDF. Let's type that in. I get this error message: the requested URL/ASDF was not found on this server. That's exactly what I expected to happen. I typed in an address I knew didn't exist and the web server confirmed it for me. But how do we know it's a 404 error code? Depending on the website, HTTP error messages could be displayed right on the page when you try to access it. However, to be absolutely sure, you can just view the HTTP response itself. To do that, we'll have to do a bit of work. Browsers today have built-in tools that help people diagnose issues with the web browser or website itself. Since I'm using Chrome, I'm going to use the Chrome Developer Tools. Let me go ahead and do that. So I want to click on this. I get into Tools. And then click on Developer Tools. This will open up the Developer Tools side by side to my web browser. Developer Tools is a great resource for testing and debugging issues with the website or browser. We won't go through this tool though. If you want to learn more, you can check out the supplemental reading. For now, we just want to see the HTTP response code. To get to that, I'm going to go to the Network tab here and refresh my page. If I try to go to google.com/ASDF, I'll see the request I made in the left-hand side here. If I click that, I'll see the status code says 404 not found. Pretty neat, right? HTTP status codes that start with 4XX indicate an issue on the client side. The client tried to do something that it couldn't, like enter a bad URL, access something it wasn't authorized to do, etc. The other common HTTP status codes that you might see start with 5XX. These errors indicate an issue on the server side. The web server that hosts this web content is experiencing issues, and hopefully their server administrators are looking into it. HTTP status codes tell us more than just errors. They can also tell us when our request is successful, which is denoted by the codes that begin with 2XX. HTTP status codes can tell us a lot about an issue with a website. If you encounter one that you aren't familiar with, just look it up. It'll probably tell you exactly what the issue is. For a list of HTTP status codes, take a look at the supplemental reading. Well, you've done it again. You've covered a lot of information in this module about software and platform services. You learned about IT infrastructure services that help a business stay productive, like communication services. You learned about security services that keep information secure between web browsers and servers. You also learned about platform services that are used to deliver applications to users. Now you can put that knowledge to the test in a short test we've cooked up for you. In the next module, we'll talk about managing users, computers, and policies using directory services. You're doing an awesome job. I know we covered a lot, but stick with it. You got this. Congratulations! You're almost done covering the essential IT infrastructure services involved in an organization. You're so close. You got this. In the last module, we learned about the software services used in an organization like communication software, security, and file storage services. Then we talked about platform services involved in organizations that build a software product. Finally, we learned about some of the servers that support those organizations like web and database servers. In this module, we're going to learn about the last major IT infrastructure service, directory services. It's the beginning of the end. Ready? Let's jump in. Have you ever looked up someone's phone number in a phone directory? Or used a directory listing at a shopping mall to find a specific store? A directory server essentially provides the same functionality. A directory server contains a lookup service that provides mapping between network resources and their network addresses. It's used to organize and look up organizational objects and entities, ranging from things like user accounts, user groups, telephone numbers, and network shares. Instead of managing user accounts and computer information locally on every machine, all that information can be stored on a directory server for easy access and management. The ideal enterprise quality directory server should support replication. This means that the stored directory data can be copied and distributed across a number of physically distributed servers, but still appear as one unified data store for querying and administering. Why is replication important? It provides redundancy by having multiple servers available simultaneously. So there'll be minimal disruption to the service in the event that one of the server explodes. Replication also decreases latency when you access the directory service. By having replicas of your directory server located in each office, you're able to answer directory service queries more quickly. The directory server should also be flexible, allowing you to easily create new object types as your needs change. Access to the information stored in the directory server database should be accessible from a variety of OS types and from the designated areas of the corporate network. Directory services are useful for organizing data and making it searchable for an organization. This is achieved through the use of a hierarchical model of objects and containers. The containers are referred to as organizational units, or OUs, and they can contain objects or more organizational units. This is similar in organizational structure to a file system. OUs are like folders which can contain individual files or objects for a directory service. OUs can also contain additional folders. The management benefits of this structure are pretty clear. Can you imagine trying to keep your music library organized if there was no such thing as subfolders? Crazy! This hierarchical structure can be used to convey additional information about what's stored within. Take your directory structure as an example. You may have an OU called users, which contains all user accounts. Within this OU, there could be additional OUs which represent the actual team structure of your organization. The users OU could contain additional OUs like sales, engineering, and marketing, which include the user account objects for the individuals that belong to these teams. This structure can be used to convey differences between these sub-OUs of users. For example, we could enforce stricter password requirements for members of engineering without affecting sales or marketing. Sub-members inherit their characteristics of their parent OU, so any changes made to the higher level users OU would affect all sub-OUs, including sales, marketing, and engineering. Someone with the responsibilities of a systems administrator, whether that's a system admin or IT support specialist, would be responsible for the setup, configuration, and maintenance of the directory server. This includes the OS itself, on which the directory service would run. Standard OS management tasks are involved here, like ensuring that updates are installed and configuring standard services. Other responsibilities include the installation and configuration of the directory service itself, so installing the service and configuring any related services. If multiple servers are used in a replication setup, this needs to be configured too. It's very likely that the hierarchy and overall structure of the directory itself would also be up to the sysadmin to design and implement. Well, that covers the high-level overview of what exactly a directory service is. We'll dive deep into more specific details later in this course. But for now, let's review some of the concepts we just covered with the short quiz. Then let's meet back at the next video where we'll do a more detailed rundown on how to implement directory services. Directory services became an open network standard for interoperability among different software vendors. In 1988, the X.500 directory standard was approved and included protocols like Directory Access Protocol or DAP, Directory System Protocol or DSP, Directory Information Shadowing Protocol or DISP, and Directory Operational Bindings Management Protocol or DOP. Alternatives to DAP were designed to allow clients to access the X.500 directory. The most popular of these alternatives was Lightweight Directory Access Protocol, or LDAP. Since these are open standards for communication and access for directory services, a bunch of different implementations of these services cropped up. There are offerings from Apache, Oracle, IBM, and Red Hat, but we'll cover two in more detail later in this module. The first is Microsoft's implementation, which is referred to as Active Directory or AD. It has some customization and added features for the Windows platform. There are also open source implementations of directory services using LDAP. A popular example of this is OpenLDAP, which we'll also cover in greater detail. OpenLDAP supports a wide range of platforms like Windows, Unix, Linux, and various Unix derivatives. In addition to the server software, there are also client tools used for accessing and administering a directory server. Microsoft offers Active Directory Users and Computers, or ADUC, which works well with Microsoft's Active Directory Server. There are also other more open tools that can be used to interface with a lot of other directory server implementations. Along with clients for administering and managing a directory server, there are also client applications that can interface with and query a directory server. All major OS platforms support integrating into a directory server for login and authentication purposes. The advantage here is that this allows for centralized management of user accounts. We'll cover the details of centralized management in the next lesson, so don't worry too much about that right now. When looking at specific implementations for your directory server, you'll want to consider OS support. Not just the server that will be running the directory service itself, but also what OSs your client fleet runs and the compatibility or support for your directory services. You can read more about why this is important in the next reading. The job of a systems administrator is to, well, administer systems. Sysadmins have a set of systems they're responsible for, and they have to manage those systems so they're available to serve their function to the organization. For example, as a sysadmin, I might be responsible for making sure that all of the servers in my network are kept up to date with security patches and application updates. Should I go around and log into each server, checking each one at a time? What if I need to manage user accounts on end user devices? Should I go to each employee's desk and set their account up that way? I guess I could, but that would be super time consuming and probably inconsistent. Instead, what I want to do is use centralized management, a central service that provides instructions to all of the different parts of my IT infrastructure. Directory services are one of these services. Remember in earlier lessons when you created accounts and gave them access to resources on your computer? Imagine that you work for an organization that has dozens, hundreds, or even thousands of computers and people who use them. You can't possibly go into each of those computers to set them up. Directory services provides centralized authentication, authorization, and accounting, also known as AAA. When computers and applications are configured to use directory services for AAA services, decisions about granting or denying access to computers, file systems, and other IT resources are now centralized. Now, you can create a user account once, and it's available for the entire network at once. Easy. Well, sort of. You will learn a lot more about AAA services in an upcoming course. For now, you should understand that your directory service will be responsible for granting or denying access to computers, file systems, and other IT resources. Now, let's go one step further. Let's say you have a network file system that you need to give everyone in the IT department access to. You could set up the network share, then give it a list of user accounts to grant access to the share. But what happens when someone new joins the IT department? What about when someone leaves? Instead of granting access based on who you are, what if you granted access based on what you do? In most organizations, access to computer and network resources is based on your role in the organization. When you manage access to resources on a computer and on the network, you'll often grant and deny access based on user groups. User groups can be used to organize user accounts in all sorts of ways. You might create groups for buildings that people work out of, or the person's role in the organization, or really almost anything else. What's important is that you use groups to organize accounts based on the way that you'll manage them. If you are a systems administrator, then you might have permission to do things like creating user accounts and resetting passwords. You're allowed to do that because of your role as a systems administrator. If you add another systems administrator to your organization, you don't want to have to find out all of the things that a sysadmin should have access to, then grant them individual account access to each of those resources. That would just take forever. Instead, we'll create a group for sysadmins and add all system administrators to that group. Then we can give the system administrators group access to any resources they need. If you or another person change roles in the company, then all you have to do is change the groups that you're part of, not the rights that you have to directly access resources. We call this role-based access control, or RBAC. Controlling access to resources isn't all you can do. You can also centralize configuration management. Just like you don't want to run around to every computer to configure user accounts, you wouldn't want to do that to set up printers, configure software, or mount network file systems. By centralizing the configuration management of your computers and software, you can create rules about how things should work in your organization. There are many ways to centralize your configuration management. An easy way to get started is with as simple a tool as logon scripts that run each time someone logs on to a computer. Later in this module, we'll look at Active Directory and its group policy objects, which are a way to manage the configuration of Windows machines. There are also dedicated configuration management frameworks like Chef, Puppet, or SCCM that can be used for super simple or super powerful configuration management. These are outside the scope of this module, so check out the supplemental reading right after this video for more information. Before we jump into directory services, Let's talk about the underlying protocol that's used in directory services called LDAP, or Lightweight Directory Access Protocol. LDAP is used to access information in directory services like over a network. Two of the most popular directory services that use LDAP are Active Directory and OpenLDAP, which we'll talk about more in upcoming lessons. There are lots of different operations you can use in LDAP. You can add a new entry in the directory server database, like creating a new user object called Christy. You can delete an entry in the directory server database, you can modify entries, and much, much more. When we say entry, we're referring to the LDAP entry format or LDAP notation for records in the directory service. An LDAP entry is just a collection of information that's used to describe something. Take a look at this example. Don't worry too much about what this says. The format of LDAP entries basically has a unique entry name denoted by DN or distinguished name, then attributes and values associated with that entry. So CN is the common name of the object. In this case, since it's a person, we use Devon Sridharan as the name. OU is the organizational unit, such as a group, and in this case, sysadmin is used. DC is domain component, so example.com is split into example, then com. Again, it's not necessary to remember these attributes. You can reference them in the next reading. The takeaway here is that LDAP notation is used for entries in directory services to describe attributes using values. If you were around when phone books were used, you might remember that these big old books contained the names, addresses, and phone numbers of people in your neighborhood or community who wanted their information to be publicly listed. This is way different from the phone book or contact list you have in your mobile phone. The people who are in your contacts directory gave you their phone numbers for your use only. When using LDAP, there are different authentication levels that can be used to restrict access to certain directories, similar to those big public phone directories or those private mobile phone directories. Maybe you have a directory that you want to make public so anyone can read the entries in the directory, or maybe you just want to keep that data private to only those who need it. We'll discuss how LDAP does this authentication and what methods it uses. We talked about the different operations you can do with LDAP, like add, remove, or modify entries in a directory. Another operation that you can perform is the bind operation, which authenticates clients to the directory server. Let's say you want to log in to a website that uses a directory service. You enter your account login information and password. Your information is then sent back to the website. It will use LDAP to check if that user account is a user directory and that the password is valid. If it's valid, then you'll be granted access into that account. You want your data to be protected and encrypted when it's completing this process. There are three common ways to authenticate. The first is anonymous, then simple, and the last is SASL, or Simple Authentication and Security Layer. When using anonymous binding, you aren't actually authenticating at all. Depending on how it's configured, anyone could potentially access that directory, just like our public phone book example. When you use simple authentication, you just need the directory entry name and password. This is usually sent in plain text, meaning it's not secure at all. Another authentication method that's commonly used is SASL authentication. This method can employ the help of security protocols like TLS, which you've already learned about, and Kerberos, which we'll discuss in a minute. SASL authentication requires the client and the directory server to authenticate using some method. One of the most common methods for this authentication is using Kerberos. Kerberos is a network authentication protocol that is used to authenticate user identity, secure the transfer of user credentials, and more. Kerberos by itself can be a complex topic that we'll revisit in the IT security course. If you want to learn more about Kerberos right now, you can check out the supplemental reading right after this lesson. Once the client has successfully authenticated with the LDAP server or directory service, the user will be authorized to use whatever access levels they have. In the next few lessons, we're going to go dive deeper into two of the most popular directory services that use LDAP, Active Directory and OpenLDAP.
The hardest part of my career has easily been joining Google. I joined in 2002 when the company was quite small. All men, for the most part. I was the only woman in the room most of the time. And the way I got through it was to find that thing that I wanted to be the expert at, find the thing I wanted to achieve, and to really focus on that every day. Break it down into small pieces, and celebrate your milestones when you hit them. And then at the end, I had achieved something that no one else in the team could have. They had all tried, and I was the one who got it done. And so I get to sort of reflect on that occasionally and think, oh yeah, I did that. Every time a packet passes between an end user's computer and Google, it crosses a barrier that I put in place for the first time. So I got more and more interesting projects, and people began to rely on me more. And it really helped me overcome the shyness. It helped me overcome my questioning of whether or not I belong here, because I actually got to contribute and in a meaningful way.
Welcome back. In this lesson, we'll learn more about Active Directory, or AD, the native directory service for Microsoft Windows. Active Directory has been used to centrally manage networks of computers since it was introduced with Windows Server 2000. If there are computers running Windows in your organization, then AD probably plays a huge role. Active Directory works in a similar fashion to OpenLDAP. It actually knows how to speak the LDAP protocol and can interoperate with Linux, OS X, and other non-Windows hosts using that protocol. When you use Active Directory to manage a fleet of Windows servers and client machines, it does a lot more than just provide directory services and centralized authentication. It also becomes the central repository of group policy objects, or GPOs, which are ways to manage the configuration of Windows machines. We'll show you how to do this later in this lesson. Now, let's take a look at a typical Active Directory domain and see what it contains. Active Directory administration relies on a whole suite of tools and utilities. We're going to use a tool called the Active Directory Administrative Center, or ADAC. ADAC is a tool that we'll use for lots of the everyday tasks that you'll learn in this course. It's great for getting work done and for learning how things work behind the scenes, as you'll see. Remember that, much like file systems, directory services are hierarchical. Everything that you see in Active Directory is an object. Some objects are containers, which can contain other objects. Several of the default containers are just called containers, and they serve as default locations for certain types of objects. Another type of container is called an organizational unit, or OU, which we talked about in an earlier lesson. You can think of an OU like a folder or directory for organizing objects within a centralized management system. Ordinary containers can't contain other containers, but OUs can contain other OUs. That's a little confusing, so to show you the hierarchical structure of AD better, I've clicked this button over the left-hand pane to switch ADAC to tree view. There are lots of things listed here. ADAC tells us what kind of object each of these are and gives us a description for some of them. We're not going to work with all of these, but we want to call out some parts of the directory that are more common to work with. The very first node in this tree is our domain. A domain will have a short name like example and a DNS name like example.com. Objects, particularly computers in the domain, will be given a DNS name that lives in the domain's DNS zone. There's actually one level of hierarchy above a domain that we don't see in this tool, and that's a forest. If you look at the logical shape of a domain, it looks like a tree, so the name even makes sense. A forest contains one or more domains. Accounts can share resources between domains in the same forest. In our example environment, example.com is the only domain in the forest. The next example that we'll look at is computers. This container is where new AD computer accounts are created. So if I go here, you can see my computers. Computer accounts are created when a computer is joined to the AD domain. The next thing that we'll look at is domain controllers. This container is where domain controllers are created by default. Next, we'll look at users. This container is where new AD users and groups are created by default. The servers that host copies of the Active Directory database are called domain controllers or DCs. Domain controllers provide several services on the network. They host a replica of the Active Directory database and group policy objects. DCs also serve as DNS servers to provide name resolution and service discovery to clients. They provide central authentication through a network security protocol called Kerberos. As I mentioned, we'll talk more about Kerberos in the IT security course. For now, what you should understand is that domain controllers get to decide when computers and users can log onto the domain. They also get to decide whether or not they have access to shared resources like file systems and printers. This allows system administrators to make changes to the network really quickly and easily. If someone new joins the organization, sysadmins can create a user account for them, and almost immediately, every device on the network knows who that person is. If someone changes jobs in the org or leaves, a sysadmin can disable or delete their account, and within seconds their access to devices adjusts. It's common for most domain controllers in the Active Directory network to be the read-write replicas. This means that each have a complete copy of the AD database and are able to make changes to it. Those changes are then replicated to all other copies of the database on other DCs. Replication is usually quick, and the last change wins in almost all cases. This isn't perfect, but it works for most tasks. Some changes to the AD database can only be safely made by one DC at a time. We task those changes to a single domain controller by granting it a flexible, single, master operations, or also known as FSMO role. We won't go into depth here on the nitty-gritty details around what each of these FSMO roles are responsible for and how they operate, but you can check out the next reading for more. If your job will involve domain controller management, you'll need to understand how to assign FSMO roles and recover from DC failure. In order for computers to take advantage of the central authentication services of AD, they have to be joined or bound to Active Directory. Joining a computer to Active Directory means two things. The first is that AD knows about the computer and has provisioned a computer account for it. The second is that the computer knows about the Active Directory domain and authenticates with it. From that point forward, the computer can authenticate to Active Directory just as any users who log onto the computers are able to. Managing Active Directory isn't just a big topic, it's a huge topic. There are system administrators who spend all their time just managing AD. We're going to spend some time showing you some of the most common tasks that a sysadmin will need to do in an Active Directory environment. When an Active Directory domain is first set up, it contains a default user account, administrator, and several default user groups. Let's do a rundown of the most important groups. So I'm going to first get into my Active Directory window. And as you can see, I'm on example.com, and we'll run through the users. Domain admins are the administrators of the Active Directory domain. The administrator account is the only member of this group in a new domain. Remember how a local administrator or root on a computer is able to make any changes they want to the operating system? Users in the domain admins group can make any changes they want to the domain. Since a domain can control the configuration of all of the computers that are bound to it, domain admins can become local administrators of all of those machines too. This is a huge amount of power and responsibility, so don't add accounts to this group lightly. Enterprise admins are administrators of the Active Directory domain. They also have a permission to make changes to the domain that affect other domains in multi-domain forest. The administrator account is the only member of this group in a new domain. Enterprise admin accounts should only be needed on a rare occasion, like when Active Directory Forest is being upgraded to a new version. Domain users is a group that contains every user account in the domain. If you want to give access to a network resource to everyone in the domain, you don't need to grant access to every individual account. You can use domain users. Each computer that's joined to the domain has an account too, so we have a default group for them also. Domain computers contains all computers joined to the domain except domain controllers. Domain controllers contains all domain controllers in the domain. I'm going to be able to do everything in this lesson because I'll be playing the role of a domain admin in my example organization. As a systems administrator or IT support specialist, you might also be a domain admin or enterprise admin.
Because of the power that gives you to make changes in Active Directory, you should never use a domain admin account as your day-to-day user account. It's too easy to make a mistake that affects the entire organization. Domain admin accounts should only be used when you're deliberately making changes to Active Directory. Got it? Your normal user account should be very much like other user accounts in the domain, where your permissions are restricted just to those resources that you need to have access to all the time. If there are some administrative tasks that you need to perform a lot as a part of your day-to-day job, but you don't need to have broad access to make changes in AD, then delegation is for you. Just like you can set NTFS DACLs to give accounts permission in the file system, you can set up ACLs on Active Directory objects. If you'd like to learn more about this more advanced topic, check out the next reading. Let's start administering Active Directory. First up, we'll take a look at user account administration. If you have systems administrator responsibilities, you might be involved in joining machines to the Active Directory domain. Remember from our introduction to AD that computers can be joined or bound to Active Directory. Joining a computer to Active Directory means two things: that AD knows about the computer and has provisioned a computer account for it, and that computer knows about the Active Directory domain and authenticates with it. Over here, I'm logged into a Windows computer that isn't joined to a domain. This is called a workgroup computer. The name comes from Windows workgroups, which are a collection of standalone computers that work together. Windows workgroups aren't centrally administered, so they become harder and harder to manage as the size of the network grows. We want central administration and authentication in our network, so let's join this computer to the domain. Let's look at the GUI for this first, then PowerShell. So I'm going to go ahead and click Computer, then System Properties. As you can see, this computer is under a workgroup. So what we need to do is we need to join this machine to the domain. To do that, I'm going to go ahead and click Change Settings. Click on Change. In the Computer Name and Domain Changes window, you can see the computer can either be a member of a domain or a workgroup, but not both at the same time. So I'm going to go ahead and select the domain right here. And I'm going to go ahead and enter our domain name, which is example.com. Now, when I click OK, this computer will reach out on the network to find a domain controller for my AD domain. Once it finds the DC, I'll be asked for a username and password to authorize the computer to be joined to the domain. So I put in my domain admin username and password, which I'm going to do right now. Voila! There you go. My machine is now joined to my domain. The domain controller creates a computer account in the domain for this computer, and this computer reconfigures itself to use AD authentication services. This will require a reboot, so let's jump over to the Active Directory Administrative Center to see what it looks like on that end. Alright, so I'm at my Active Directory window, and I'm going to go ahead and click Computers. And alright, there it is. I can see my computer in the computers container. Now, my new computer will use this Active Directory domain for authentication, and I can use group policy to manage this machine. We can join computers to the domain from PowerShell too. I've got this computer over here that also needs to be joined to the domain, so let's use a CLI this time. So I'm going to go ahead and type in add computer, then domain name, example.com, and server that I'm going to connect to, DC1. That was nice and simple. Now I'm prompted for my credentials again, which I'm going to enter. And that's it. By default, this command won't automatically reboot the machine to complete the domain join. If I add the restart parameter, the command will take care of that too. One final thing. Over the years, there have been several versions of Active Directory. We refer to these versions as functional levels. An Active Directory domain has a functional level that describes the features that it supports. If you're interested in seeing some of these changes to Active Directory over time, take a look at the next reading on AD functional levels. If you administer Active Directory, you'll need to know what your domain and forest functional levels are, and may someday need to upgrade your Active Directory forest or domain to support new features. So let's look at the properties on this domain. So this domain is at version 2016. We can also find this from PowerShell like this. So type in get ad forest and then get ad domain. See the forest mode and domain mode properties? Now that you know what your domain's functional level is, you can find out what AD features it supports. Check out the supplemental reading for a whole lot of additional documentation and training materials if you want a deeper dive into AD administration. Alright, now that we've joined all these computers to our domain, what are we going to do with them? In this lesson, we're going to talk about how to use Active Directory group policy to configure computers and the domain itself. Like we mentioned before, directory services are databases that are used to store information about objects. The objects represent things in your network that you want to be able to reference or manage. One of these object types in AD is Group Policy Object, or GPO. What's a GPO? It's a set of policies and preferences that can be applied to a group of objects in the directory. GPOs contain settings for computers and user accounts. You may want different software preferences for the marketing team, the legal team, and the engineering team. Using group policy would help standardize the user preferences for each of these teams and help make it more manageable for you to configure. Using group policies, you can create login and logoff scripts and apply them to users and computers. You can configure the event log, telling the computer what events should be logged and where the logs should be sent. You can say how many times someone can enter the wrong password before their account is locked. You can install software that you want to be available and block software that you don't want to run. You heard the boss. And this is just the beginning. You can create as many group policy objects as you want, but they don't do anything until they're linked to domains, sites, or OUs. When you link a GPO, all of the computers or users under that domain, site, or OU will have that policy applied. You can use other tools like security filtering and WMI filters to make group policies apply more selectively. We'll get into that a bit. A group policy object can contain computer configuration, user configuration, or both. These are applied at different times. Computer configuration is applied when the computer signs into the Active Directory domain. This will happen each time the computer boots into Windows, unless it's disconnected from the network at the time it's booted up. User configuration is applied when a user account is logged onto the computer. In each case, once a GPO is in effect, it's checked and enforced every few minutes. Remember when I said that GPOs contain policies and preferences? What's the difference? Policies are settings that are reapplied every few minutes and aren't meant to be changed even by the local administrators. By default, policies in the GPO will be reapplied on the machine every 90 minutes. This ensures that computers on the network don't drift from the configuration that system administrators define for them. Group policy preferences, on the other hand, are settings that in many cases are meant to be a template for settings. System administrators will choose settings that should be the default on computers that apply the GPO. But someone using the computer can change the settings from what's defined in the policy, and that change won't be overwritten. How do domain-joined computers actually get their GPOs? When a domain-joined computer or user signs into the domain by contacting a domain controller, that domain controller gives the computer a list of group policies that it should apply. The computer then downloads those policies from a special folder called sysvol that's exported as a network share from every domain controller. This folder is replicated between all of the domain controllers and can also contain things like login and logoff scripts. Once the computer has downloaded its GPOs, it applies them to the computer. We won't get into too much detail about the sysvol folder, but I've included links to more information in the next reading. Lastly, many policies and preferences in GPOs are represented as values in the Windows registry. The Windows registry is a hierarchical database of settings that Windows and many Windows applications use for storing configuration data. The GPO is applied by making changes to the registry. The Windows operating system and Windows applications read the registry settings to determine what their behavior should be. You can read more about the Windows registry in the supplemental reading. Group policy management is another huge topic. We'll only cover the basics of it in this course. Now that you understand a little bit about what group policy objects are, let's dig in and see how you use them to manage Active Directory and AD joined computers. The most important tool we'll use for creating and viewing group policy object is called the Group Policy Management Console, or GPMC. You can find this in the Tools menu of Server Manager or by running gpmc.msc from the command line. You can see that the layout of GPMC is similar to other management tools that we've used in Active Directory. On the left, we see the structure of Active Directory. GPMC adds several containers to its GUI. These aren't AD containers or OUs, they are management interfaces that only show up in GPMC. The Group Policy Objects container will hold all of the GPOs that are defined in the domain. The WMI filters container is used to define powerful targeting rules for your GPOs. These filters use properties of Windows Management Instrumentation, or WMI, objects to decide whether or not a GPO should apply to a specific computer. This is a more advanced topic, but if you want to dive in a little deeper, check out the link in the supplemental reading. Group Policy Results is a troubleshooting tool that's used to figure out what group policies apply to a computer and user in your network. You would use this tool to check on group policies that are already applied to a computer or user. On the flip side, Group Policy Modeling is used to predict which group policies will apply to a computer or user in your network. You'd use this tool if you wanted to test a change to your GPOs, OUs, or WMI filters before making real changes in your Active Directory. We'll go into each of these in detail as the lesson goes on. You might have also noticed that there are a couple of things missing. Remember that the users and computer containers are not organizational units. Group policy objects can only be linked to domain, sites, and OUs. If computer and user objects are in the default containers, they can only be targeted with GPOs that are linked to domains and sites. It's a good practice to organize your user and computer accounts in OUs so they can be targeted with the more specific group policies. Now, let's get started with Group Policy Objects node in GPMC and take a quick look at a GPO that already exists. In a brand new Active Directory domain, there'll be two GPOs that are automatically created: the default domain controller policy and the default domain policy. The default domain policy is, as you might guess, a default GPO that's linked to the domain. It applies to all of the computers and users in the domain. The default domain controller policy is linked to the domain controller's OU and applies, you guessed it, to the domain controllers. What we're looking at here is a settings report for the default domain policy. This GPO is designed to enforce policy decisions that we want to make for the entire domain. For example, the minimum password length policy prevents users from setting passwords that are too short. The audit account logon events policy says that the computer should create a Windows event for each successful and failed logon attempt. There are thousands of settings that can be controlled with GPO, so it can take some research to find the right setting to change in a group policy object to make a change that you want. Group policy has been around through several versions of Windows, and sometimes things aren't exactly where you expect to find them. Don't despair. There are lots of documentation online about group policies and where to find specific settings. Pro tip: something that you might find super useful are the group policy settings reference that Microsoft releases with each new version of Windows. This reference is a spreadsheet that details the GPO policies and preferences that are available and where to find them. Next, let's try changing one of the settings in our default domain policy. Before we get started, I'm going to make a backup of the GPO. I'll right-click on the policy and choose Backup. I've created a GPO backup folder on my desktop, but in a real environment, we'd want to create a network folder that's locked down to only allow domain administrators to access it. I can add a description here too to help me remember why I made the backup. Then I complete the backup wizard and I'm done. Now, I know that if I make a mistake, I can restore the policy from backup. So I'll right-click on the policy again, but this time I'm choosing Edit. This will open up the default domain policy into the Group Policy Management Editor. You can see over in the left-hand pane that the GPO is divided into two sections: computer configuration, and user configuration. Each of these is divided into policies and preferences. Inside this tree of policies and preferences is every individual GPO setting that GPMC knows about, whether it's been configured or not. Every GPO has access to the same settings that every other GPO has access to. There aren't special GPOs. Even so, it's a good practice to make different GPOs that each address a specific category of need. For example, you might have a GPO that handles all of the settings for a specific group of users, or one that handles security policies for the whole domain. With specific GPOs for specific solutions, you can link your GPOs to only the computer or users that need that policy. Since you're working with the entire universe of group policy in every GPO, it can be very difficult to tell from the editor what settings are actually configured in this GPO. We'll refer back to the settings report in GPMC for that information. It looks different, but you might notice that the settings report is laid out in the same hierarchical fashion as the GPO editor. I can see that the account lockout threshold is configured to 0 invalid logon attempts. Let's take a look at that policy in the GPO editor. I'm going to use the settings report as a roadmap to finding that policy in the editor. So let me show you how. I'm going to go ahead and right-click Default Domain Policy, hit Edit, and I'm going to have this to the side so we can look at our roadmap. So as you can see, Computer Configuration. So I click Computer Configuration, then click Policies, click Windows Settings. I'm going to click Security Settings, and then Account Policies because we're interested in the lockout policy. You can see that there are 3 policies under Account Lockout Policy. The policy column tells us the name of the policy, and the policy setting tells us the current configuration of the policy. If a policy is not defined, then this GPO won't make any changes to that setting on the computers that it's applied to. The policy name is pretty easy to understand, but I'm not sure that I understand all of the consequences of changing those values. If I double click on any of these policies, it will open up the properties dialog for that policy. Oh, what's this? There's an explain tab here. Awesome. The explain tab will tell us what the policy configures. It may also tell us what to expect if the policy is not defined, and what the default value of the policy is if it's enabled but not customized. So, looking at the explanation of the account lockout threshold policy, I see that by having it set to 0, accounts will never be disabled for failed login attempts. That's not what I want in my domain, so I'm going to change this value. Oh, interesting. It looks like this policy has some dependencies on other policies. Okay, I'm going to accept these defaults, and now I'll see that all 3 of these policies in the account lockout policy have been configured. So how do we save these changes? As soon as you hit apply or OK in a group policy management editor dialog, the change is made in the GPO immediately. Almost right away, computers can receive the update and start applying it. That might not be what you wanted. When you need to make changes to a production group policy, you should test them first. For example, I was playing around with the default domain policy, which is linked to the whole domain. So I've just immediately made it so all user accounts will be locked if they enter their password incorrectly once. Whoops. Where's the undo button? Guess what? There isn't one. Don't worry. This is why we made a backup before starting to work on this policy. Let's restore the policy from backup and undo this catastrophe waiting to happen. Back in the Group Policy Management console, I'm going to right-click on Default Domain Policy in the Group Policy Objects, and then select Restore from Backup. This wizard remembers the last place that I backed up a GPO and assumes that's where I want to restore from. So intuitive. Now, it lists each of the GPO backups that are in the folder that we choose. The name of the policy and the time that it was backed up are listed here, along with any descriptions that we provided when we did the backup. If I click on View Settings, it will launch my web browser with a settings report of the backup. Cool, right? Okay, I need to get this policy restored so my users don't get locked out of their accounts. The summary dialog shows me what I'm about to do, so let's go there. This all looks right, so I'm going to click Finish and make sure that my policy has been restored. Perfect. My backup has been restored and my mistake has been undone. As you've seen in this example, before making changes to a GPO, you should always back it up. But what's another way I could have prevented this mistake? That's right, I could have tested my changes. There are lots of ways to do this. I'll summarize some simple steps here and provide additional documentation in the supplemental reading. Some organizations will have established best practices for testing GPO changes in their environment. If that's the case, then you should follow those standards. You might need to follow a change management process too, in order to notify others in the organization about the changes that you are about to make. What I'm going to show you is just one way of adding some safety to GPO changes. Let's say I have a GPO called example policy. Good name, right? I want to make changes to example policy, but I want to test the changes first to make sure that I don't break production machines. First, I set up a testing OU that contains test machines or user accounts. If example policy is usually linked at example.com finance then computers, then I can create example.com finance computers test and put testing machines in the test OU. This lets the test machines keep all of the existing production GPOs, but gives me a place to link a test GPO that will override production. Let me go and show you how I do that. So I'll click example, click new, click OU, then type in finance, and click OK. Then create another OU for my computers. And then underneath that, I'm going to go ahead and make a test OU so I can test my GPO and hit OK. Next, I make a copy of the GPO that I want to change and call it something like test example policy. Let me show you how I do that. So this is one policy that I have. I'm going to hit copy, go to my group policy objects, hit paste. And I want to say use the default permission for the GPOs because we want to make a copy, of course, and hit OK. As you can see, it's called copy of master. I'm going to rename this to test example policy. Enter. Now I can make the changes that I want to test in test example policy and link it to my test OU. And let me show you how I link that. I'm going to go into my OU finance, computers, and then test, right-click test, and then I want to say link an existing GPO, which is going to be my test example policy right here, and then hit OK. After I confirm that my changes work the way that I expected, I can make a backup of the test policy, then import the backup of test example policy to the production example policy. This makes some extra work for me since I'm a systems administrator, but I also benefit from added safety and peace of mind. By testing my changes on a copy of the GPO on test machines, I make it much harder to accidentally break production machines. Your organization might be using Advanced Group Policy Management, or AGPM, which is a set of add-on tools from Microsoft that give you some added revision control abilities in GPMC. If you do use AGPM in your organization, you should follow best practices for GPO version control using AGPM. I've included a link to those best practices in the next reading. We've edited a GPO and seen some ways to make editing GPO safe. Now, we need to know a bit more about how to understand all of the policies that are applied to a specific machine or user account. Next up, GPO inheritance and precedence. I'll see you there. If you follow the practice of creating specific GPOs to address specific categories of needs, you can end up with a whole lot of policies linked at many levels of your Active Directory hierarchy. Group policy objects that control security settings are a really common place where this can happen. Systems administrators are responsible for protecting the security of the IT infrastructure. So, it's a good practice to create a very restrictive GPO that uses very secure, conservative security policies and link that to the whole domain. This gives you a secure default policy, but some users or computers might not be able to do what they need to with those very conservative policies in place. The finance department might need to use Excel macros that are disabled in your default security policy, for example. So we can create GPOs that relax some of those security settings or policies in the OUs that contain those computers or users. Another example might be that we have a group policy object that standardizes the desktop wallpaper of all computers, but we have computers that are public access kiosks that need to have a different wallpaper. In any of these cases, you can have computers or user accounts with multiple GPOs assigned to them that contradict one another by design. So what happens when there are two or more contradictory group policy objects that apply to the same computer? When computer is processing the group policy objects that apply to it, all of these policies will be applied in a specific order based on a set of precedence rules. GPOs are applied based on the containers that contain the computer and user account. GPOs that are linked to the least specific or largest container are applied first. GPOs that are linked to the most specific or smallest container are applied last. First, any GPOs linked at the AD site are applied, then any linked at the domain, and then any OUs in order from parent to child. If more than one policy tries to set the same policy or preferences, then the most specific policy wins. To see what I mean, let's look at this AD structure. As you can see my structure, I have multiple OUs. We have my IT OU, we have my sales OU, I also have my research OU. And I also have my sites in Australia, India, and North America. If you have a computer in the India site and the example.com sales computer OU, then Active Directory would apply group policy objects that are linked to the India site, the example.com domain, the sales OU, and the computers OU in that order. That's not all though. You can actually link multiple GPOs to the same container. How does AD decide which order to apply the GPOs in, if there are more than one in a container? Each container has a link order for the GPOs that are linked to it. So let's look at our sales OU. The sales OU in our example domain has a GPO for network drive mapping and a GPO for configuring network printers. The link order of each policy determines which GPO takes precedence. The highest number is the lowest ranked GPO, so its settings are applied first. Network printers, sales is applied first, and network drives, sales is applied last. If anything, the network drive policy contradicts the network printer policy, then the drives policy wins out. Let's summarize this so far. The highest numbered link order in the least specific container is applied first, and the lowest numbered link order in the most specific container is the last GPO applied. The last GPO to modify any specific setting wins. In the Group Policy Management console, we can see the precedence rules in action. I'm going to switch to the Computers OU in Group Policy Management. I can see that there's a policy linked here called Computer Security Policy. I want to increase this. By switching from the Linked Group Policy Objects tab to the Group Policy Inheritance, like so, I can see that objects in this OU will actually have quite a few policies applied. The precedence column tells us which policy will win if there are conflicting settings, and the location column tells us where the policy was linked. You might have noticed that there are no site link policy listed here. That's because you can have computers from many different AD sites in the same OU. So, site-based GPO links aren't represented in this summary. When you add all of the group policies together for a specific machine and apply precedence rules to them, we call that the resultant set of policy, or RSOP, for that machine. When you're troubleshooting group policy, you'll often compare an RSOP report, pronounced RSOP, to what you expect to be applied to that computer. There are a lot of ways to get an RSOP report. We'll use the Group Policy Management console for now, and look at the other methods when we start troubleshooting. Let's check on what group policy objects will apply when one of our sales staff logs onto their computers. I'll right-click on the Group Policy Results node in GPMC and select Group Policy Result Wizard. So let me go and do that. This wizard will walk me through generating a resultant set of policy report for the computer and user of my choice. The computer that I'm using to run this report will make a remote connection to that computer and ask it to run the report. The report will then be visible in my local GPMC. I'd like to see the RSOP when Emmett is logged into his computer, which is Emmett PC01. Let me go and do that. So I'm going to hit Next, and I'm going to search for his computer. So I'm going to hit Another Computer, hit Browse, and I'm going to type in Emmett PC01 and hit OK. The group policy results in Wizard is super simple. First, I enter emmet-pc01 as a computer that I want to run the report on. By default, the wizard will only run an RSOP report for computer configuration. Since I want to see the user configuration for Emmet2, I'll select display policy setting for him, which is actually already selected by default. So what we're going to do is we're going to hit next, and it's going to take us to the summary of selections. And then we're going to hit next, and to generate the report, we hit finish. You can only select users from this list who've already logged on to this computer in the past. That's it. I'll review my selection in the summary dialog, then finish the wizard. I'm left with a new item under the group policy resultant node in GPMC, and it contains a resultant set of policy report that I just requested. Great. This RSOP report contains everything that we need to understand what policies apply to a computer or user. It includes a whole lot of detail about where the computer and user are located in AD, what their security group memberships are, and more. I'm going to set that aside for the moment and focus on the settings sections of the report, which I'm going to scroll down to. This looks a lot like the information you see in the settings tab of a GPO, but instead of only showing you the settings modified by a single GPO, you can see the combined effect of all of the applied GPOs. The winning GPO column tells you which GPO ultimately took precedence for each policy and preference. Amazing, right? Remember, I'm making a remote request from my group policy management console to Emmet's PC01 to run this report. There are a bunch of reasons that this could fail to work. Emmet PC01 may be powered off. It could be disconnected from the network or have firewall rules that prevent me from running the report remotely. If I'm not a local administrator on the machine, I won't be able to run the report. In any of these cases, if I need that RSOP report for troubleshooting, I might have to run commands locally on Emmet's PC01. We'll cover additional troubleshooting techniques in a future lesson.
As a systems administrator or IT support specialist, you might be called on to troubleshoot issues related to Active Directory. Let's go through some of the most common troubleshooting tasks that you may encounter. This lesson will introduce you to tools that will help you troubleshoot these scenarios. Keep in mind, these are only examples. Since we're working with complex systems, there are lots and lots of ways for things to not work. Your greatest tool is to learn about these systems and understand how they function. Thoughtful troubleshooting and research are your friends. One of the most common issues you might encounter is when a user isn't able to log into their computer or isn't able to authenticate to the Active Directory domain. There are many reasons this might happen. They may have typed their password with cap locks button on. They may have locked themselves out of their computer, accidentally changed a system setting, or it could be a software bug. It's important to think about the steps to troubleshoot and remember to ask questions about what happened. Make sure to look at the exact conditions under which the failure occurs and any error message that accompany the failure. This should be enough information to get you started down the right path to troubleshoot. Let's just talk for a moment about the most common types of failures that can lead to a user account authentication issue. As we discussed in an earlier lesson, if a user enters a wrong password several times in a row, their account may be locked out. People sometimes just forget their passwords and need the assistance of an administrator to sort things out. Make sure to review our earlier lesson on managing user and groups in Active Directory if you need a refresher on resetting user passwords. If a domain computer isn't able to locate a domain controller that it can use for authentication, then nothing that relies on Active Directory authentication will work. If you remember from the customer support module in the first course, anytime you troubleshoot an issue, start with the simplest solution first. This could be a network connectivity issue and nothing specific to Active Directory at all. If the computer isn't attached to a network that can route communications to the domain controller, then this must be fixed. You also learned about network troubleshooting techniques in an earlier module, so we won't repeat any of them here. Any networking issue that would prevent the computer from contacting the domain controller or its configured DNS servers, which is used to find the domain controller, could be an issue. Now, why is DNS so important? In order for the computer to contact a domain controller, it needs to find one first. This is done using DNS records. The domain computer will make a DNS request for the SRV records matching the domain that it's been bound to. If the computer can't contact its DNS servers, or if those DNS servers don't have the SRV records that the computer is looking for, then it won't be able to find the domain controller. The SRV record that we're interested in are underscore LDAP dot underscore TCP dot DC dot underscore MSDCS dot domain dot name, where domain name is the DNS name of our domain. So I'm going to go ahead to my PowerShell, and I'm going to go ahead and type in resolve dash DNS name type SRV name LDAP dot underscore TCP dot DC dot underscore MSDCS dot example.com. Well, that looks good. I should see an SRV record for each of my domain controllers. And I do. Perfect. Now, if I can't resolve the SRV records for my domain controllers, then my DNS servers may be misconfigured. How might they be misconfigured? Well, my domain computers need to use the DNS servers that host my Active Directory domain records. This will often be one or more of my domain controllers, but it can be a different domain server. Either way, the appropriate DNS servers to use for your domain computers should be known and documented. Compare the configuration of the machine to the known good configuration and see if it needs to be adjusted. On the flip side, if you're resolving some SRV records, but they appear to be incomplete or incorrect, then in-depth troubleshooting may be required. I've included a link to more information about this in the next reading. One more thing to call out. Depending on the configuration of your domain and your computers, it's common that local authentication will continue to work, for a little while at least. Once someone logs into a domain computer, information required to authenticate that user is copied to the local machine. This means that after the first login, you'll be able to log in to the computer even if the network is disconnected. You won't be authenticated to the domain or authorized to access any domain resources like shared folders. Just because someone is able to log in doesn't mean that they're able to find a domain controller. Another issue that can prevent users from authenticating has to do with the clock. Kerberos is the authentication protocol that AD uses, and is sensitive to time differences. I'm not talking about local time zones here. I mean the relative UTC time. If the domain controller and computer don't agree on the UTC time, usually within 5 minutes, then the authentication attempt will fail. Domain computers usually synchronize their time with domain controllers with the Windows time service, but this can sometimes fail. If the computer is disconnected from a domain network for too long, or if the time is changed by software or a local administrator to be too far out of sync, then the computer may not automatically resync with a domain controller. You can manually force a domain computer to resync by using the w32tm/rsync command. I've included links with more information about this in the next reading. Now, let's talk a bit about troubleshooting group policy issues. A common issue that you might have to troubleshoot is when a GPO-defined policy or a preference fails to apply to a computer. You might learn about this failure in a number of ways, like a person in your organization telling you that something on their computer is missing or not working. If you're using GPO to manage configuration on your machines, then maybe there will be a piece of software that should be present. Or there may be a mapped network drive that's missing, or a number of things. The common factor will be that something that you've created a GPO to configure won't be configured on one or more computers. Let's look at the 3 most common reasons that this might happen. The first, and possibly most common type of GPO failure, has to do with the way group policies are applied. Depending on how your domain is configured, the group policy engine that applies policy settings to the local machine may sacrifice the immediate application of some types of policies in order to make logon faster. This is called fast logon optimization, and it can mean that some GPO changes take much longer to be automatically applied than you might expect. Also, the group policy engine usually tries to make GPO application faster by only applying changes to a GPO instead of the whole GPO. In either of these examples, you can force all GPOs to be applied completely and immediately with gp_update/force. If you want to be really thorough, you can run gp_update/force/sync. Adding the /sync parameter will make you log off and reboot the computer. Some types of group policy can only run when the computer is first booted, or when a user first logs on, so a log off and reboot is the only way to make sure that a forced update to GPO has a chance to apply all of the settings. Replication failure is another reason that a GPO might fail to apply as expected. Remember that when changes are made to Active Directory, those changes usually take place on a single domain controller. Those changes then have to be replicated out to other domain controllers. If replication fails, then different computers on your network can have different ideas about the state of directory objects, like group policy objects. The logon server environment variable will contain the name of the domain controller that the computer used to log on. Remember that you can see the contents of the variable with this command in PowerShell, which is $environment:\logon server. And it shows me DC1. And you can also get the same results using command prompt, which uses %logon server %. Knowing which domain controller you're connected to is useful information to have if you suspect a replication issue. From the Group Policy Management console, we can check on the overall health of the group policy infrastructure. I'm going to select my domain and take a look at the Status tab. This tab will summarize the Active Directory and sysvol replication status for the domain. It may be showing a result from a recent test, so I'm going to force it to run a new analysis by clicking on Detect Now. What we want to see is that all of our domain controllers are listed under domain controllers with replication in sync. If they are, then we can be sure that there are no replication issues that will affect our group policy objects. If we do see any domain controllers in the domain controller with replication in progress list, then we may have a replication issue. Depending on the size and complexity of your Active Directory infrastructure and the reliability and throughput of the network links between your AD sites, it's possible for a replication to take a few minutes to complete. If replication doesn't complete in a reasonable amount of time, you may need to troubleshoot Active Directory replication. In the supplemental reading, you'll find a handy guide to help you through this more advanced topic. We've focused on the simplest cases for managing group policy, but the reality is that controlling the scope of a group policy object can get super complicated. Take a look at the supplemental reading to learn more about this topic too. If you're trying to work out why a particular GPO isn't applying to a computer, the first thing to do is to run the resultant set of policy, or RSUP. You can use the Group Policy Management console like we did in an earlier lesson, or you can run a command on a computer directly to generate the report. The GP result command will help us out there. If I run gp result/r, you can see that I get a summary report in my terminal. Let me go and show you that. So I'm switching to my PowerShell. gp result/r. The report's being created, and I get this report. If I want the full report, like I get from my GPMC, I can run gp result/h filename.html. I want to do gp result/h and then test.html. This will give me a report that's an HTML web page that I can open in my browser. So let me go and get that. Okay, so with this report in hand, I want to look for some things. Is the GPO that I want to apply listed? Was it linked to an OU that contains the computer that I'm troubleshooting? Is the GPO that I care about listed under applied GPOs or under denied GPOs? If it was denied, what was the denied reason? Did another GPO win for the policy or preference that I'm trying to configure? Each GPO can be configured with an ACL called a security filter. Is the security filter set to something besides authenticated users? If so, then that may mean that you have to be in a specific group in order to read or apply the GPO. Each GPO can also be configured with the WMI filter. A WMI filter lets you apply a GPO based on the configuration of the computer. WMI filters are powerful but expensive and easy to misconfigure. This is because they look at Windows Management instrumentation values to decide if a policy should apply or not. For example, You could create a GPO that installs a piece of software, but only if a WMI reports that a specific piece of hardware is present. These filters are expensive because they require the group policy engine to perform some sort of query or calculation on every computer that's linked to the policy, but then only apply the GPO to computers that match the filter. Many policies and preferences can be configured to apply to the computer or to users as they log on. Did you mean to configure a computer setting but accidentally configure a user setting, or the reverse? There's a really in-depth group policy troubleshooting guide in the supplemental reading that you should refer to if you get into a really tricky GPO troubleshooting session. Okay, we've really covered a lot out here. If you aren't clear on any of the concepts we've covered, that's okay. Just make sure to rewatch the lessons. Remember though, that the more you work with Active Directory and the group policy, the more familiar you'll become with them. If you use what you've learned about these systems combined with your research skills, you can troubleshoot just about anything.
In the last lesson, you dove headfirst into the popular directory service, Active Directory. You learned how to add users, password, groups, and even modify access level for groups using group policies. Another popular directory service that's used today is the free and open source service OpenLDAP, which stands for Lightweight Directory Access Protocol, operates very similar to Active Directory. Using LDAP notation or LDAP data interchange format or LDIF, you can authenticate, add, remove users, groups, computers, and so on in a directory service. OpenLDAP can also be used on any operating system, including Linux, Mac OS, even Microsoft Windows. However, since Active Directory is Microsoft's proprietary software for directory services, we recommend that you use that on Windows instead of OpenLDAP. But it's helpful to know that OpenLDAP is open source, so it can be used on a variety of platforms. There are a few ways you can interact with an OpenLDAP directory. First, you can use the command line interface and pass in commands to create and manage directory entries. You can also use a tool like PHP LDAP admin, which offers you a web interface that you can use to manage your directory data, much like the Windows Active Directory GUI that you're familiar with. You can read more about how to set up OpenLDAP and PHP LDAP admin in the next reading. In this lesson, we'll give you a high-level overview of the operations you can do in OpenLDAP via commands and how they work. To begin, we'll just open the OpenLDAP package using this command. I want to get into my Linux environment and type up this command: sudo apt get install slap d ldap utils. Put my password in and accept. Once you install the packages, it'll prompt you to enter in an administrator password for LDAP. So let's go ahead and do that. And then hit OK. Then confirm your password. Then hit OK. Now that it's installed, we're actually going to reconfigure the slapd package so that we can fine-tune our setting. To do that, we're going to run the following command. I'm going to clear my window and then run sudo dpkg reconfigure slapd. This is going to ask us a bunch of questions about our new setup. We won't cover all of these options, but you can learn more about them in, you've guessed it, the supplemental reading. For now, let's just fill out the settings with these values. So the first option is omit OpenLDAP server configuration. I'm going to go ahead and say no. Next, DNS domain name. It's similar to Windows AD. This is our organization domain. Let's use example.com. And then hit OK. Organization name. Let's use example. Administrator password. Let's do the same thing that we entered before. For the database, let's use MDB. Do you want the database to be removed when slapd is purged? Let's go ahead and say no. Then it's asking us if we would like to move the old database. We're going to say yes for now. and they'll say allow LDAP version 2 protocol. I'm going to say no. That's it. Now you have a running open LDAP server. We're really cooking now. Let's keep going. It's easier to manage Open LDAP through a web browser and tool like PHP LDAP admin. But you can also use command line tools to achieve the same result. I'd recommend you look into setting up PHP LDAP admin if this is your first setup with Open LDAP. For instructions about how to set up PHP LDAP admin, check out the supplementary reading. In this lesson, we're going to quickly run down a few of the commands that will allow you to add, modify, and remove entries in your directory. To begin using command line tools, you need to use something known as LDIF files, pronounced LDIF. We've already seen LDIF format or LDAP notation in action. It's just a text file that lists attributes and values that describe something. Here's a simple example of an LDIF file for a user. Even without understanding what the syntax of this file is saying, we can infer that it's talking about an employee named Cindy who works in the engineering department of the company, example.com. We've talked a little bit about what the attributes are referring to in an earlier lesson, but you can refer to the supplemental reading if you want to know what the specific fields mean. For our purposes here though, we just want to see a high-level overview of how this works. Once you've written your LDIF files, you're practically done. Depending on what task you want to do to your directory, you'd run commands like these. LDAP add. This takes the input of an LDIF file and adds the context of the files. LDAP modify. As you can guess, this modifies an existing object. LDAP delete. This will remove the object that the LDIF file refers to. LDAP search. This will search for entries in your directory database. It's not important to know the syntax of these commands. You can always look up the syntax on official documentation. But as you can see, it's not scary to work with OpenLDAP. It operates in a very similar way to Windows Active Directory or AD. You can take this knowledge and populate your directory just like you did in Windows AD. If you're curious about the syntax of these commands, check out the supplemental reading on using LDIF files and LDAP commands. Again, if you're considering OpenLDAP as your solution to your directory service needs, I'd recommend looking into the web manager tool, PHP LDAP admin, that we've included a link to in the next reading. Just like Windows AD, this topic can be pretty extensive, so think about which directory solution best fits the IT needs for your organization. There are lots of reasons why you might want to deploy the help of a directory service like OpenLDAP or Active Directory while working in a systems administration role. Directory services are great for centralized authentication, keeping track of what computers are in your organization, who can access them, and more. Make sure to play around and familiarize yourself with OpenLDAP or PHP LDAP admin to get a better sense of how these directory services work. Checking out the official documentation is always a good place to start. By now, you've learned about all the essential IT infrastructure services. The next topic we'll shift to is how to make sure all the hard work you put into your IT infrastructure doesn't go to waste by learning about disaster recovery and backups. Your hard work is really paying off. High five to that. Now, take a moment to complete the quiz we put together for you. Then we'll meet you back in the next video.
Have you ever had something unexpected and catastrophic happen to a piece of tech you owned? Maybe you dropped your cell phone and it shattered, or spilled a glass of water all over your laptop. I know it's happened to me, and no, it's not fun. While hardware may be hard to replace, data can be even harder to get back, especially lost photos of special moments, important documents, or more. In this module, we're going to arm you with tools you need to be prepared for these accidents, so you can minimize the impact and loss of data. Alright, let's get right into it. Data recovery. What exactly is data recovery? If you've ever broken a cell phone, you probably lost some good pictures along with the phone itself. Data recovery is a process of attempting to recover the data that's lost from the broken phone, But this is just one example of attempting to recover from unexpected data loss. Data recovery, in general terms, is the process of trying to restore data after an unexpected event that results in data loss or corruption. Maybe a device that contains data was physically damaged, or an attacker performed malicious actions, or malware deleted critical data. Whatever the cause, the effect is the same. You've suddenly lost some really important data and you need to figure how to get it back. How you go about trying to restore this lost data depends on a few factors. One is the nature of the data loss. If a device has been damaged, you might be able to recover data from the damaged hardware. This could involve using data recovery software, which can analyze failed hard disks or flash drives and try to locate and extract data files. Another factor that would affect your data recovery is the presence of backups. If you're lucky, or you had the foresight to plan for the unexpected, you have data backed up, and you can restore the data that was lost. Data recovery is an important part of an IT system or organization. Since data is a critical component of any business operations, as an IT support specialist, part of your role is to ensure that this data is available and protected from corruption or loss. So, if something goes wrong, the organization can continue with their business operations with minimal disruptions. That's why it's critical to be able to recover from unexpected events that could impact your business data. When an unexpected event occurs, your main objective is to resume normal operations as soon as possible, while minimizing the disruption to business functions. By the end of this module, you'll have practical tools and methods that you can use to protect your data. One of the most important techniques you'll learn is how to effectively back up your data. The best way to be prepared for a data loss event is to have a well thought out disaster plan and procedure in place. Disaster plans should involve making regular backups of any and all critical data that's necessary for your ongoing business processes. This includes things like customer data, system databases, system configs, and financial data. You will learn more about how to design and implement a data disaster plan throughout this module. And lastly, you'll learn more about what IT folks call a postmortem. Imagine that something did go wrong with your systems and you had to use a disaster plan. You might have discovered issues when recovering your data that wasn't covered in the disaster plan. A post-mortem is a way for you to document any problems you discovered along the way, and most importantly, the ways you fix them so you can make sure they don't happen again. Being unprepared for a major data loss event can and has severely impacted businesses. In the upcoming lessons, you'll learn how to prepare for data loss, which is a key part of any IT role. If you're interested in hearing more about how real companies have been impacted by unexpected data loss, check out the supplementary reading. Otherwise, we're going to kickstart our journey of data recovery with learning how to back up data. Ready? Let's get started.
So you want to protect your organization from critical data loss. Good instincts. But where do you start? Let's run down some of the key things to keep in mind when designing a data backup and recovery plan. The first thing to figure out is what data you need to back up. In a perfect world, you should only be backing up data that's absolutely necessary for operations and can't be found in another source. So things like emails, sales databases, financial spreadsheets, server configurations, and databases should all be included. But what about the downloads directory on your laptop? Is it really necessary to back up all those cat pictures too? Probably not. Backing up data isn't free. Every additional file you back up takes up a little more disk space, increasing the overall costs of your backup solution. Once you've figured out what data you like to back up, you should find out how much total data you currently have. But it's not enough just to think about what your backup storage requirements are right now. Your organization may continue to grow and your backup should grow with it. Make sure that you account for future growth and choose a solution that's flexible enough to easily accommodate increases in data backups. Data can be backed up either locally to systems on-site, or the backup data can be sent off-site to remote systems. Both approaches have positives and negatives and can help reduce different risks. The advantage of on-site backup solutions is that the data is physically very close. This makes accessing the data a lot quicker. You won't need as much outbound bandwidth since you aren't sending the data out of your internal network. If you need to restore data from backups, that should happen pretty quickly since the data is close at hand. But what if the unexpected event is a building fire? Now the systems we were backing up along with the backup server have been lost in the fire. Yikes. We've lost everything. This is why offsite backups are strongly recommended. This involves making backups of critical data, then sending the backed up data offsite to remote systems in a different physical location. This could be another backup server that you control in a different office or a cloud-hosted backup service. But there are trade-offs. Yeah, offsite backups better prepare us for catastrophic events that can wipe out data from an entire office. But sending data offsite means that you need to transmit the data outside of your network. This means you need to consider things like encryption and bandwidth. Your internet connection will be used to transmit the backup data. Depending on how much data you're sending offsite and how fast the internet connection is, this could take a lot of time. Another important thing to consider is encryption of backups. Since backups will often contain sensitive and confidential business data, it's important the data is handled securely and stored in a way that prevents unauthorized access. When sending data offsite, it's especially important to make sure that data is being transmitted securely, preferably encrypted via TLS. But that's not all. The resulting backup data that's stored should also be encrypted at rest. This is just good security practice. In the next video, we'll discuss some of the practical tools that you can use to back up your data.
So you're looking to bring a backup solution into your organization, but how do you choose between a DIY backup system or one of the many cloud providers? Well, let's start by looking at the trade-offs between the two. On-site or self-managed backups could be as simple as buying a commercial NAS device, loading it with a bunch of hard drives and sending data to it over the network. This would definitely work, but it might not be the best long-term solution. How do you grow the disk capacity when you need more storage space? How do you handle a failed hard disk? Because hard disks will fail eventually. By the way, it's important to call out these options aren't mutually exclusive. There's nothing stopping you from implementing both on-site and off-site backups. Actually, it's often recommended to have both if it's within your organization's budget. One more thing that you should consider when evaluating the backup strategy for an organization is backup time period. How long do you need to hang on to backups for? This answer will impact your long-term storage needs and overall cost to maintain a backup system. One approach, which balances cost with convenience, is to archive older data using a slower but cheaper storage mechanism. The standard medium for archival backup data storage is data tapes. These are a lot like audio cassette tapes since they use spools of magnetic tape run through machines that allow data to be written to and read back from the tape. Tape storage is pretty cheap, but isn't as easy or quick to access as data stored on hard drives or solid-state drives. This storage system is usually used for long-term archival purposes where data isn't likely to be needed. If it is needed, some delay in getting the data isn't a concern. There are dozens and dozens of backup solutions available. We won't cover specific ones since there are way too many, but we'll cover some common tools and give you some examples of backup solutions available. One is the command line utility rsync. Rsync isn't explicitly a backup tool, but it's very commonly used as one. It's a file transfer utility that's designed to efficiently transfer and synchronize files between locations or computers. Rsync supports compression and can use SSH to securely transfer data over a network. Using SSH, it can also synchronize files between remote machines, making it super useful for simple automated backups. Apple has a first-party backup solution available for their Mac operating systems called Time Machine. It operates using an incremental backup model. Time Machine supports restoring an entire system from backup, or individual files. It even allows restoring older versions of backed up files. Microsoft also offers a first-party solution called Backup and Restore. This has two modes of operation. There's a file-based version where files are backed up to a zip archive, or there's the system image where the entire disk is saved block by block to a file. File-based backups support either complete backups or incremental ones. System image backups support differential mode, only backing up blocks on the disks that have changed since the last backup. If you want to learn more about these tools, follow the links in the supplemental readings after this lesson. There's one last super important topic when it comes to backups: testing them. The field of IT is littered with tragic tales of IT support specialists and sysadmins attempting to restore data from a backup after a data loss incident, only to discover that their backups are invalid. That's not just embarrassing, it's completely terrifying. The takeaway here is that it isn't sufficient to just set up regular backups. There's only half of the equation. The other half is a recovery process, and that process needs to be tested regularly. Restoration procedures should be documented and accessible so that anyone with the right access can restore operations when needed. You don't want your time off to be interrupted because your colleague back at the office doesn't know how to restore the SQL database from the backup, right? Of course not. So document the procedure and make sure you regularly test the documentation to make sure it works now and in the future. This process is called disaster recovery testing and is critical to ensuring a well-functioning recovery system. Disaster recovery testing should be a regular exercise that happens once a year or so. It should have different teams, including IT support specialists, going through simulations of disaster events. They'll test and evaluate how well prepared or unprepared your organization is for lots of unexpected events. These scenarios can be anything from a simulated natural disaster like an earthquake to a fictional event like a horde of zombies shutting down an office. If that's the case, backups will be the least of your worries, but it's still important. Whatever the scenario, it'll help your IT teams test their emergency procedures and figure out what works and, most importantly, what doesn't. These simulated events are the perfect way to discover any gaps in your planning. If you discover that you aren't protected from data loss in any given scenario, it's an opportunity to learn and fix this gap without risking real data loss. Sounds like a win-win, doesn't it? So we've talked about how important backups are and why you should be backing up any important data and some tools that can use to help you back up data. But how exactly do you decide when and how to back up data? Well, let's explore those options. There's a couple of ways to perform regular backups on data that's constantly changing. You can do a full backup on a regular basis, which involves making a copy of the data to be fully backed up. The full unmodified contents of all files to be backed up is included in this backup mechanism, whether the data was modified or not. In the case of data that doesn't change very often, like operating system configuration files, this approach can be inefficient. You're backing up multiple copies of data that isn't changing, which wastes space and uses bandwidth unnecessarily. That doesn't seem like the best idea, does it? A more efficient approach is to only back up files that have changed or been created since the last full backup. This is called a differential backup. The advantage is that you aren't storing backups of duplicated, unchanging data. Only the files that changed are backed up, saving us some storage space and time to perform the backup. But you wouldn't want to completely stop taking full backups. Over time, you'll wind up tracking and storing lots of copies of files that change a lot, which will also take up more and more disk space over time. To avoid this, it's a good practice to perform infrequent full backups, while also doing more frequent differential backups. How often you perform a full backup will depend on how far back you want changes to be tracked. Let's say we perform full backups once every week and differential backups daily. In the worst case scenario, we'll lose close to 24 hours of data changes. That's not bad. Another efficient way to back up changing data is to perform regular incremental backups. While a differential backup backs files that have been changed or created, an incremental backup is when only the data that's changed in files is backed up. This is even more efficient in terms of both disk space and time required compared to differential backups. Again, you'll want to use frequent incremental backups along with less frequent full backups. But because this approach only stores differences in the files that have changed since the last incremental backup, it's possible that all incremental backups are needed to fully reconstruct the files. If one of these incremental backups is missing or corrupt, it might not be possible to recover data any more recently than the last full backup. Another drawback is that recovery might be more time-consuming. This is because the most recent version of backed up data has to be recreated by integrating the last full backup with each incremental backup that follows. For super large files that are changing frequently, this could require a lot of time to process. One more thing backup systems can do to help save space is file compression. When creating a backup, all the files and folder structures will be copied and put into an archive. Archives are useful for keeping files organized and preserving folder structure. Besides archiving the files, backups can also be compressed. This is a mechanism of storing the same data while requiring less disk space by using complex algorithms. Those are way too complicated to go into detail here, but it's important to call out that not